from Iceland with Daniel. Oh, hello.
Hello. Say hi, Eve. Say hi. Say hi.
So
You're
Jeff
not going to
Spencer
sleep,
says,
are
"Don't wanna
you?
be
You're not going to
too
go to sleep.
exact with that L9000 model." Okay. If you if anybody's watching the stream of it, just make sure you have your audio turned off on that computer. It's a common mistake, even with myself.
Good reminder. I was just doing that. Almost the top of the hour. Shall we kick off the kickoff party?
Yeah, we're streaming live right now,
Hi, everyone.
and our mics are hot.
Scott, are we going to begin with Debbie waltzing, or shall we jump right into some introductions?
It's completely up to you guys.
Go
Well,
for it.
I know we're going to get to hear some more Debbie waltzing later, so why don't we get started with our party?
Okay.
Welcome. And Scott, I'll hand it off to you to kick us off.
Okay. All right. So I will take us to our wind sync trim. And here we are. And here we are. We have started officially the Global Moon Party and the kickoff for the International Observe the Moon Night. And so with us, I'm just part of a team of wonderful individuals. We started out this idea with Vivian White at Night Sky Network. And she has invited on just an amazing group of support people and speakers and presenters from all over the country. I think from different parts of the world as well. I think all the way out to Iceland, which is totally cool. And so, later in the program, we even have Amy Kaminsky, Senior Policy Advisor for the Office of the Chief Scientist at NASA. So it doesn't get any cooler than that. Why don't you take it away, Vivian and Kayla?
Thank you, Scott. I am so excited to kick off the International Observe the Moon Night season with this Global Star Party. Scott has been amazing at Explore Alliance, helping us to coordinate herd all the cats. He's an expert cat herder. Thank you so much, Scott. It's really lovely to be here. And thanks for being the man behind the curtain, figuring all of the things out.
Absolutely my pleasure.
I am Vivian White. I work at the Astronomical Society of the Pacific in San Francisco, California, where I am thrilled to be able to work on the NASA Night Sky Network. I've got my colleague, Dave Prosper, here with me, who is running quite a few things behind the scenes too. Thanks, Dave. And I want to introduce the other host of this evening, Kayla Berry. She works at NASA Goddard and has just been an amazing coordinator of getting this all together. So we're really excited to kick off the International Observe the Moon Night, we'll say week.
Yes.
Kayla, welcome.
Thank you, Vivian. Thank you, Scott. And hello, everyone. We are so excited to be here with you. My name is Kayla Berry, and I work in the Solar System Exploration Division at NASA's Goddard Space Flight Center. I am also the host and observer liaison for International Observe the Moon Night, which is a worldwide public engagement event that happens every year. In just a few moments, the director of the program, Andrea Jones, is going to tell you all about it. But before we get there, I would just like to provide a quick peek at some of the exciting things that are coming our way tonight. Our first hour of the program is going to focus on all the ways that you can get involved with International Observe the Moon Night. Pro tips, resources, activities, We are here to welcome you, help you figure it out, and welcome your ideas if you're someone who has done this before. In the second hour of our program, we are going to focus on citizen science and education resources. So we will hear from, as Scott mentioned, Amy Kaminsky, who is part of the Artemis Prizes, Challenges, and Crowdsourcing program. We will get to hear from special guests at Slooh about some educational resources that are available through their program. From our colleagues at the Lunar and Planetary Institute, we have an awesome hands-on activity demonstration for you. And we're also very excited to welcome Brandon Rodriguez from JPL Education with an additional activity demonstration. And we're going to kick off that hour with a citizen science program. So if you are interested in getting involved with the science that NASA does, tune in, that's for you. We're really excited to share some opportunities there. Our last hour is going to go over perspectives from a few different NASA folks. In addition to the ones that you'll hear from earlier in the program, we'll get a moon in review, recent and upcoming lunar news with Staci Tiedeken. We'll get to hear from Ernie Wright, who is a data visualizer at NASA's Scientific Visualization Studio. We'll see a couple of really cool ways to tour the moon virtually that you can do at home on your own. And we'll get to hear from the person behind the Astronomy Picture of the Day series, which has been a favorite of mine for a long time. And I'm so pleased that we get to hear from Robert later today. Throughout the program, we are very, very excited to be able to bring you some musical offerings from the wind quintet Wind Sync and others. And that's just a quick preview of some of the things that are coming our way this evening. So with that, I'll kick it back to Vivian and Scott for any more words before we jump in.
I am just reading through some of the comments on YouTube, and I was going to say, please let us know where you're joining from. I know we have people from all over the globe for this global moon party, so it's really lovely to just know that you're out there and tuning in.
Yeah, and from us at Explore Alliance, it's just really great to be a part of it and to be the guys that are connecting the wires to run this. I'm just as excited as all of you guys are in watching these amazing presenters. So thank you.
Thank you, Scott. All right, let's kick it off. We have with us to start the evening one of International Observe the Moon Night's founding members and now the public engagement lead, who is running the International Observe the Moon Night with an incredible team of people, many of whom you'll meet tonight. I want to introduce Andrea Jones, who's going to share with us some more about International Observe the Moon Night. She is a scientist at NASA Goddard and works with, just as I got it together, works at the Solar System Exploration Division. So Andrea, welcome. We'd love to hear from you and hear all about your experience with the International Observe the Moon Night, because you've been doing this for quite a while.
I have, but it is so wonderful to be here with all of you. And I think I'm sharing, hold on, I think it messed up. What's going on? Let's see, is this, okay. Is this, are you seeing something?
Yes.
Excellent, okay. I was hoping
that looks better. That's
okay,
good.
Good.
That's the best right there.
Excellent. All right, well, thank you so much. And thank you all for being here. Thank you so much to Vivian and Kayla and Scott and the whole Night Sky Network and the whole team that's putting this together, and to all of our presenters for being here, and to all of you for joining us this evening or this morning or whatever time it is where you are. But this is our first global moon party that we've ever done. We've been doing this event for a long time now, and I'll tell you a little bit about it. But I'm really, really happy to be part of this first global moon party and to be here with all of you as we are trying out something new. It's always fun to have a new thing together. But as we're getting underway here, let's see if I can change. Okay. So for those of you who are not familiar with our program, International Observe the Moon Night is a worldwide celebration of lunar science, exploration, celestial observation, and our personal and cultural connections to the moon. So you can see a few ways how people are participating here, but really it's one day each year that we invite everyone on Earth to go out, look at the moon, observe the moon, celebrate the moon together. And though I said one day, it's really a series of days. So as Vivian said, we do have one official date, and this year the official date is October 16th, but we have a window because we know that date doesn't work for everyone, just like it didn't for this particular party. So this year from October 8th until the 24th, we are celebrating the moon in lots of different ways. Some people are having virtual events like this one, others are in person. There's maybe a few less of those right now during our global pandemic, and places where you can gather safely, that's another choice. So there's lots of resources that we have on our website on moon.nasa.gov/observe. And we want people to take those materials, take the inspiration to go out, look at the moon and learn about the moon, and then make it your own. So depending on your interests, perhaps you work in a museum, a science center with a classroom, and you want to have an event. That's great. We want you to tailor it for your own audience and the resources that you have available. Or maybe you want to observe the moon at home with your family or with your friends or as an individual lunar observer. And we think all of that is wonderful and just want everyone to go out and have a wonderful, meaningful experience for them with the moon. And we try to provide a lot of resources on our website to do that. So let's see. All right, so this event or this program was inspired by the Lunar Reconnaissance Orbiter and our twin or our sister spacecraft, the Lunar Crater Observing and Sensing Satellite. Back in 2009, we had a big event at NASA Goddard in Maryland and at NASA Ames in California, celebrating we're at the moon. We had these big we're at the moon parties and people seemed to like them. And so we thought, hey, we can keep this up. And so we kept having events to invite everyone in the world we started a lot smaller. We started, thinking just our local communities, and we thought national, and we never did that because right away people around the world expressed interest in doing this with us. And so we've kept it up since then. But the Lunar Reconnaissance Orbiter has been with us the entire time. This is a spacecraft that's still at the moon today and is helping really reshape our understanding of our nearest neighbor in space. So here I'm showing a few of our data sets. We have all the way on the left, the near side and far side visible imagery with our cameras. The middle is showing you the topography of the surface, which we actually know better than the topography of the Earth or any other large planet. We actually know the shape of Bennu better than the moon now, but Bennu is a little bit smaller. And then we also monitor the temperatures of the lunar day and the lunar night and during lunar eclipses to see how the surface changes and understand some of the physical and chemical properties of the surface with temperature as well, and also help prepare for going back to the moon and what kind of temperature environment, what kind of radiation environment, what kind of impact cratering rate are we seeing so that we can protect our equipment and our astronauts when we return there. And the bottom images are one of those new impact craters, which I just think is so beautiful. We're watching the moon change before our eyes. And it's gorgeous, it's dazzling, and this is a process that happens throughout the solar system on every solid body and beyond as well. So we're learning about that as well as admiring it. The middle image is really just because I think it's gorgeous. It's a sunrise or sunset, I forget which one, over the northern pole of the moon, which is just stunning. And we're going to have views like this at the South Pole as well. And Ernie Wright later will show you some of our great imagery or really the visualizations of what we're preparing that our astronauts will see at the South Pole. And over on the right, I include that because we've been to the moon, but there are still so many mysteries about the moon. So this is a crazy feature called Ina D that we don't really understand what it is yet. It might be evidence of recent volcanism on the moon, a volcanism type that we do have on the Earth, but we really need to learn more about all of these features. The moon still has many, many secrets that we would love to learn more about. All right, so some other things about our event. So International Observe the Moon Night takes place every year in September or October on a Saturday is always the official event date. But again, we have a date range to be more flexible for everyone's schedules out there. And it's always around first quarter. This is kind of a late phase for us. It's a little more in the gibbous phase than we normally have it. But this was just a great time to look at the moon when you see that line between day and night. You're seeing the Terminator, and the Terminator is a great place to look at the rugged topography of the moon. The cratered landscape really pops out when you see that line between day and night. So that's why we don't normally do a full moon, even though we encourage you to go out anytime you can possibly see the moon, but we specifically pick a phase where you can see that Terminator, and then can look through telescopes if you have any available, or binoculars. And that's a really, really nice place to look at the moon. And each year also, Brian Day from NASA Ames, who's on our team, makes moon maps for us. So it used to be one moon map. Now he's gone above and beyond, and we have several moon maps. We have 3 different ones this year made for Northern Hemisphere and Southern Hemisphere. And if you go to our website on moon.nasa.gov/observe, under the resources, you can find this. And each one of these features, he picks new ones every year and then describes them for you. And he always picks them along the Terminator. So in case you get to look through a telescope or binoculars, or even just with your naked eye, there are some really, really neat features to look for. And this year, he also made video flyovers in Moontrek for each of these sites. So you can take a look at those, and some will be later on in the broadcast as well. Oh, all right. So let me step ahead here. Okay, so International Observe the Moon Night is a great time to talk about lunar science and exploration and what's been going on in the past year with lunar science. So Staci Tiedeken, my colleague, is going to be talking with you later about a lot of different things that have been going on this past year in lunar science. So I won't go into great detail here, but some sneak peeks of what she might talk about are sunlight, or on the moon. We thought that was a dry place. Turns out you can actually get little bits of water even on the sunlit surfaces of the moon, which is really, really incredible. We also found some great places potentially to look for samples. If we go collect rock samples on the moon again, where can we find some that will tell us about the deep interior, or at least, deeper in the mantle than we get on most parts of the crust, to learn about what the interior of the moon is like. So this was another release this past year. And then we're also doing some field work here on Earth to learn about how to explore the moon, how to prepare to safely explore the moon in areas of rich scientific interest, and keep our astronauts safe, keep our equipment safe, and really get the best science out of our expeditions to the moon and beyond. And our next speaker is from Iceland. I had the great pleasure to go there not too long ago and learn about how we're doing some of these preparations as well. And we're going to feature this on our NASA Expeditions Twitter account the week after International Observe the Moon Night, if anyone's interested. But there's many more scientific advances to talk about, and some of these are collected in a slide deck that Staci Tiedeken also is going to post to our website. So I hope you turn in for her talk, and I also hope that you check out our website for more information. All right, I wanted to share just a few more things with you about our event. So, I think I'm flipping ahead here. So in addition to celebrating lunar science and exploration, this is also a great time to be celebrating the moon in our culture, our personal connections to the moon, and the moon in art and science, in arts as well. So we have a lot of different ways to observe the moon. We love different cultural stories. Some of them will be featured in this broadcast as well. But you really have we really encourage people to observe in creative ways. So you can touch the moon. We have some 3D prints there. We, of course, have images from spacecrafts. You can go outside and look at it. You can also make moon art. You can take pictures of the moon. You can share them with us on social media if you have a fun way that you're observing the moon. Show us what you're doing. Share that with the world. And you can do that through all kinds of social media channels. And we link to those on our website, or Observe the Moon on any social media platform. And you can share that with the world and with us. We'd love to see how you are observing the moon. So last year, this is our map of participation in the middle there. So this is an event where hundreds of thousands of people get together each year to observe the moon, to learn about the moon, to celebrate the moon. And by being here today, you are a part of that. So we're so glad that you're here to learn about the moon with us. And you can see lots of different ways, again, that people have been participating. So we've been updating our website. We're providing new resources and graphics. We encourage you to, observe in groups where you can, or observe, outside and all on your own or with your family friends. I really like the moon because this time when I am distanced from a lot of my friends and family, we're all able to look at the same moon together. So I think that's really, really special. And you can find this and a lot more on our website. So thank you so much for being here. Thanks again to our organizers and our hosts. And I'm really, really looking forward to having a great night here with you all. So thank you so much.
All right, thank you, Andrea, for that introduction to International Observe the Moon Night. As Andrea mentioned, our next guests are calling in all the way from Iceland, and I want to extend a huge thank you to our next three guests who are all calling in from time zones where it is very late at night. So without any further delay, I'd like to welcome Daniel Lieb from the Iceland Space Agency and Ásdís Gunnarsdottir, a poet from Iceland, who are going to deliver our next presentations.
Thank you so much, Kayla, Vivian, Andrea. It's a real pleasure to be here. We're honored to join all of you. I'm here in lunar habitat Reykjavik. The habitat I'm actually sitting in was designed by students at the Rhode Island School of Design under the leadership of Professor Michael Lai, who we've been working with here at the Iceland Space Agency. And this specific habitat was designed for the lunar South Pole. So I thought it would be apropos to join from mid-deck here. But without further ado, I'd like to introduce our very special guest here, Ásdís, who is a poet, a video artist here in Iceland and working all over the globe. And she's put together a very special lunar poem for us tonight. So without further ado, Ásdís.
Tunglið. Þú endurspeglar sólina og horfir á okkur frá himnum. Við lesum í þig og horfum á þig með andakt. Þegar það fullt tungl, þá finnum við það á okkur. Það hefur bein áhrif á okkur, okkar líðan. Flóð og fjara, vatnið. Þú ert andlega klukkan okkar, ert, varst og mun verða. Endurheimt í leit að vatni, kona stígur á yfirborð tunglsins, einu skrefi nær, fjöllunum á Mars, til að skoða, til að endurspegla bláa ljósið. Vatnið hér eru kristallar frá hinum endalausu skuggum suðurpóls tunglsins. You reflect the sun gazing at us from the skies. We read into you. We look at you as a signal. When the moon is full, we can feel it. It has a direct effect on us, our feelings, high tide, low tide, the water. You are our cosmic clock, are, were, and will be. In the search for water, a lady steps onto the lunar surface, one step closer to the Martian hills to explore and reflect the blue light of home. Tunglið, þú endurspeglar sólina og horfir á okkur frá himnum. Við lesum í þig og horfum á þig með andakt. Þegar það er fullt tungl, þá finnum við það á okkur. Það hefur bein áhrif á okkar líðan. Flóð og fjara, vatnið. Þú ert andlega klukkan okkar. Ert, varst og mun verða. Endurheimt í leit að vatni, kona stígur á yfirborð tunglsins, einu skrefi nær fjöllunum á Mars til að skoða, til að endurspegla bláa ljósið. Vatni hér eru kristallar frá hinum endalausu skuggum suðurpóls tunglsins. Thank you.
Yeah, thank you, Ásdís. It's really a pleasure to hear that. That's the first time I've heard the poem all the way through. Ásdís actually has been composing these words for the last few days, few weeks. So thank you. And til hamingju, congratulations to everyone for this incredible kickoff event. Here in Iceland, many of you may know that, in fact, at the beginning of the space age, the original Apollo astronauts came here to Iceland to train for their eventual landing at Tranquility Base. They came here in 1965 and 1967 for geology training missions. And since then, researchers from NASA have continued to come to Iceland with great frequency. And now with Artemis, the importance of Iceland is that much more. Both Martian research, analog research is being done here in Iceland and has been for the last couple of years. And now with the return to the moon, astronaut training will resume here in Iceland once more. And just this past summer, we were field testing the MS-2 Moon Mars analog spacesuit simulator. And we have some very special footage that's never been seen before that I'd like to share with you. And I'll be talking over it. There's no audio to the video, but this was captured just this past August. And there were actually 3 separate teams, all in Iceland this summer, all doing separate research. But I think it emphasizes the importance of Iceland for the future of space exploration. And we're just really excited to be here and be able to offer logistical support, research support for the Artemis program. And without further ado, I'd like to show you some video documentation of our field testing of the MS-2. And Scott, if
okay. Here we go.
Thank you. So this this material here was taken in the Highlands. The original Apollo training missions were all done north of Botniokul Glacier, around the volcano Askja. This is actually further south in the Highlands, Central South Highlands specifically. And here we can see one of our analog astronauts, Alex, who's an experienced Royal military aviator, actually, who was field testing the MS-2. And the goal of this project is to basically develop the most the spacesuit simulator the highest fidelity, so that we can do training here on Earth that can give us the confidence and also the data necessary to understand what's necessary for the future of spacesuits for the Artemis mission. And the specific geometry that we're looking at here with the MS-2 came from Johnson Space Center and Artemis generation XEMU spacesuits. But this spacesuit simulator specifically is designed for analog research. So it's not pressurized, and it's designed to simulate as close as possible what a spacesuit would feel like on the moon or Mars, but here on Earth. And so here we visited a number of both lunar and Martian terrains. Here you can see Alex trekking about on basaltic sands, and here we're inside of a lava tube. The importance of lava tubes, the significance for space exploration, is that, of course, on the lunar surface, we don't have a magnetosphere to protect us from solar radiation. So it's important to find shelters that can shield us from the dangerous solar radiation, cosmic radiation. And it's believed that there are lava tubes on both the moon and Mars, and that these lava tubes will potentially be a place for habitation that can shield astronauts from these harmful rays. And here you have, we have Matt Pryor, who was leading the analog endeavor for us, and he's exiting the lava tube Stefanshellir. And once again, the of course we all understand that Artemis is all about going back to the moon to stay and using it as a foothold to eventually go onwards to Mars. And here in Iceland, we have all of these terrestrial analogs in very close proximity to one another. And I think you can see clearly that if you want to eventually go back to the moon and onwards to Mars, you really should come to Iceland first. So with that, I'm going to return this back to our panel. It's a real honor to be here, and if any of you have any questions, happy to do my best to answer them.
Wonderful. Thank you so much, Daniel and Ásdís, for celebrating International Observe the Moon Night with us, and for the gift of your poetry and for this exciting science update. For now, I'd like to invite Gianluca Masi to join us just to stay with our schedule. But folks, if you have questions, please do feel free to add them in the chat, and we will do our best to get answers back to you as we are able. Our next guest, thank you so much again, Daniel and Ásdís. Our next guest is Gianluca Masi, who is a long-time International Observe the Moon Night supporter and a truly inspirational night sky and evening and dawn sky photographer. Gianluca, over to you.
Thank you very much, Kayla, for organizing this with the other colleagues. It is such a pleasure and privilege to be here and tonight, because here in Italy we are in the middle of the night, but it is cloudy, so no stars tonight, unfortunately. But earlier this evening, I could spot the moon, and it was funny because we were going to talk about our beautiful satellite. And as you told, I have been loving the International Observe the Moon Night since the very beginning, and I really believe that celebrating the moon is a great idea, not only for the science, and there is a lot of exciting science, of course, under the name of the moon, but because the moon is bringing us a lot of other meanings, because it is so much celebrated in any culture. Here in Italy, I am speaking from Rome, we have plenty of references in our culture to the moon. I can tell about many poems, many songs, many arts in general. So it is such a beautiful cosmic object, and it is bringing us so many inspirations. And as an astronomer, I started my interest in the field looking at the moon, of course, and I was attracted by his changing phase night after night, and this was bringing to me the idea that there was a rhythm in the sky, that is the moon orbiting around us. And as Andrea reminded us, looking at the Terminator of the moon every night was a joy and a discovery for me. And now I try to bring the same excitement to the other people when I have the opportunity to meet them and to talk about the moon, about our natural satellite and the night sky in general. But the moon is really a winning object. I have seen many people crying looking through a telescope when they look at the moon. And this is something I cannot describe by words. This is why from time to time, I try to take images of our natural satellite, our cosmic neighbor, how I love to call our moon. But taking images of the moon can be very easy or very hard, depending on what you really want to do. And we have now smartphones around that they can take some very nice pictures of the moon. And you also have very nice telescopes. Even amateur people have a very nice telescope they can use to grab so beautiful images that they can be used for scientific purposes, of course. But I want to share with you a few images I did here in Rome, where I live, because at some point of my life, I discovered the beauty to put together the beauty of the moon and the beauty of the place where I live. And of course, this is true for everyone. I am in Rome, but you are in your own town, your own country, and discovering this connection under the name of the beauty can be very nice, especially on the international Observe the Moon night. And I want to try to share with you a few of these sites, and I hope that you can see them. And very likely, you can even recognize a few monuments in Rome. And I particularly love to image the full moon. Yes, I know people with the experience with the moon know that observing the full moon is not the best when you really want to see details, because you basically have no shadows, no contrast. But looking at the moon from the city when the moon is full is a true experience. And here it is, for example, the full moon rising above Rome with some monuments from the city. And hopefully this is bringing to you, this connection, this beautiful connection between our satellite and our Earth. And for me, this is amazing. This is why I really love to go out there to find a place in the city from where I can see the moon showing just behind that monument, for example. And here it is, the very famous Colosseum. And again, here you have the full moon rising just behind the Colosseum. And I cannot tell the emotion I can really enjoy, I can experiment while I am facing this personally, and I really hope that this image is able to bring to you the same feelings, the same experience. And again, this is the Colosseum on the left, with the sequence showing one of the best and the most beautiful lunar eclipses I could observe in 2018, so a few years ago. And I could share this live view, at the time we were not handling with the pandemic, with literally thousands of people, and it was something truly magic. And again, this is the full moon rising behind the Colosseum as well. You understand that I love this monument, and it is a symbol of the city, of course. This is, for me, seeing the sky I love together with the city I love is really a new experience. And this is really motivating this part of my photographic work and this public outreach activity, because I invite people to try the same. So go there, just wait for the moon rising or setting, or just wait for the moon and try to put together the city, the place where you live, and the sky you love. This is something I really ask people to try, and I'm sure you will love the experience. And of course, not only the full moon, even tonight, for example, there was such a sharp crescent of the moon. You can see here the St. Peter Dome, and on the left, our beautiful satellite. I'm really amazed every time. It is like the first time, no matter, I forgot how many years ago I started observing the night sky, but the moon for me is always as the first time, because I cannot tell you the magic. Of course, I am a scientist, but my heart and my soul are the first things to enjoy the experience. Then my mind is asked to come into play. But the first reaction is in the name of the beauty we are sharing, we are seeing together. And again, this is a full moon setting at dawn. And again, here you can see the St. Peter Dome, and you here had a very peculiar eclipse, as you can see. And I had to wait for years for this exact alignment, because it is not obvious to have this kind of things, you know. And this experience, looking at the moon from the city, is also training you to wait for the right moment. This is something you can use in your personal life at some point, very likely. And again, the full moon above the great synagogue in Rome at dawn, and I really love this kind of combinations. I really hope that these images will tell you the same that I feel while I am alone early in the morning, or somewhere at sunset, just waiting for those things to happen. And here again, the St. Peter Basilica at sunset with amazing colors, with the moon and the earth shine, making possible for us to guess the entire lunar disk. And by the way, it was Leonardo da Vinci more than 5 centuries ago to try to explain the origin of the earth shine, and he was relatively right, considering it was 5 centuries ago. And you can try. I invite you to read what Leonardo wrote about the origin of this elegant, simple but so elegant effect you can see on the moon when it is so young. And again, the city, yeah, I cannot tell you how many monuments are here. It will take a lot of time, but trust me, they are, I mean, there is Rome with its most famous and important monuments, just enjoying the moon rising above it. And here, of course, there is also the local observatory with the very young moon setting, and between the moon and the observatory, there is a dot of light. It is a planet Mars. So it is quite a nice image, because we have been on the moon, we are going there again, but we are also hoping to visit Mars pretty soon. And I hope that this image will, it is like to say good luck to those taking the way to Mars. And this is from last spring. This is one of the images I really love more. And this is, as you can see, I prefer to work with my photographic equipment. I didn't use telescopes for this kind of images. This is typical photographic equipment, and I prefer to work at sunset or at dawn when I image the full moon, because you still have some light surviving around the environment. So you can enjoy both your local place and the moon rising or setting. This is why I really prefer to work at those very precise moments of the day. And again, I really can observe, I can stare at these events and these amazing shows for hours. Unfortunately, the Earth is rotating, you know, so at some point the moon will set and the show is over. Otherwise, very likely I could stay there for the eternity, because you know, you understand me, because we share the same passion for the night sky and for the moon, of course. And this is one of the last images I want to share. And this is from last August. And I'm particularly proud here because you have the full moon rising again. You have the Italian flag, and the flag is just above the building where our president is living. So there is the Italian Republic in this image together with the moon. And I was very happy. I have been trying to take this image for a few years because that day, there is a very narrow window for me to have this alignment. And the past years, I had clouds, of course. Murphy is always in action, as you know, my friends. And just to give you an idea of what a very simple photographic equipment can do, you can also image craters without having telescopes. This has been done with a 400 millimeters lens, nothing special, but you can see many features, not very different from the face we will have next week when we will celebrate the International Observe the Moon Night. And the last image, again from the moon, and as I told you, looking at the moon has a lot of meanings because it is bringing to you the science, but it is also bringing to you the dreams of many, many other people, many years before us. And they have been looking at the same moon, and they have tried to explain what they were seeing. And where that was hard, there was always poetry, as we have listened earlier, able to tell us something very beautiful about the moon. And I hope that these images will be able to hopefully invite you to enjoy the upcoming International Observe the Moon Night, because for me, it is such a very special opportunity. And I will do my best here in Italy to bring the moon to everyone. And again, I thank all of you for the opportunity to share with you my experience, my sentiments, and my love for our cosmic neighbor, our beautiful moon. Thank you very much.
Oh, that was so beautiful, Gianluca. Thank you so much.
My pleasure. Thank you so much, Vivian.
Incredible images and such passion. I think you've inspired everyone watching. Thank you.
Thank you to you.
I wanted to mention too that we put in the chat links to some observing guides for photographing the moon. And I think that if anyone wants to try that, there are some simple ways to do that, either with a cell phone or a real camera, or with a small telescope. There are lots of great options there. We encourage you all to be inspired and try that out yourself.
Thank you so much. And I'm very happy again to thank you for creating this and for the opportunity. Thank you so much.
Thank you, Gianluca. All right. Feel free to put questions in the chat, and we're happy to take those at the end. I think we'll have some time left over with any luck. I would love to introduce our next speaker, who is a friend of mine, I am happy to say, from Oklahoma City Astronomy Club. We've got Eileen Grabowski joining us, and Eileen and her team at the Oklahoma City Astronomy Club have been doing amazing lunar outreach for Observe the Moon Night, and her pictures are just, they inspire me as well. And I wanted to share those with you through Eileen. She wears many hats. She ran the Norman North High School Astronomy Club for many years, and she right now is also the teaching at the Girl Scout Astronomy Club of Western Oklahoma. I think she's running that. So with all your hats, Eileen, I would love to hear from you and how you've been observing the moon for the past few years with International Observe the Moon Night, and you've done a really great job of helping us to think of ways to do that more safely. And I would love to hear you share that with everyone else. Thank you for joining us tonight.
Thank you very much. Should I just hit the share screen button?
Sure, yeah.
Okay, let's see if I can get there. Somehow I am not seeing the host has spotlighted your video. No.
Probably do that from here too, if it's easier.
Okay, that may be the best way.
All right.
Okay.
Just a moment.
And stuff. If you can bring it up from there, it probably would be easier.
Got it.
It's giving me all sorts of weird I'm at the Girl Scout Camp Travera right now. We're about to run a special STEM night for the girls in astronomy. We're introducing the EV scope. The Girl Scout Astronomy Club is getting ready for Observe the Moon Night, so they're running a lunar station and all that good stuff. So is it coming up?
It is 1 second, and I.
Okay, all right, that's great. Thank you.
About that. All right.
Yeah, hit the, as Vivian said, I wear a lot of hats, and they keep asking me to be an officer for OKC and do things, and I said, no, not at this time. I'm very busy. I'm just taking care of, just getting retired. So could you go to the next slide, Vivian? And see if you can, okay, yeah, because you're gonna have to advance it. We've been at Norman North, we started experimenting with Mr. Pete Core, who is a parent member. He's a good electrical engineer, and he is also a very active amateur astronomer in all these groups. And so he and I have sponsored the kids. We do outreach to our local schools, and we evolved a system. He has a little 6M camera and a 6-inch telescope, and we project the moon on the ground, and the kids get to dance to it. So in October 2018, we took our show on the road with the OKC Astronomy Club, and we actually did International Observe the Moon Night at the Wheeler Ferris wheel in Oklahoma City on the south side of the river. And you can see the Ferris wheel in the background, and the kids just, here we were able to project it down, had a big moon, had a good dance floor, and the kids get to dance on the moon. Sometimes we play things like Ben Morrison's Moon Dance, or we ask them if they know how to moonwalk, and then we can see if they know Michael Jackson's Moonwalk. How about the next one, Vivian? I think it's another view. And you can see some of the kids just decide to sit. Some of them do all sorts of sit spins. But it is, a joyous event. When we do it at the schools, the kids love this. And so at the Ferris wheel, there weren't probably as many people as we have sometimes at the schools, but this was a great way to go. And then the next slide shows towards the end of the night, and people were just, before the Ferris wheel closed, I actually had former students come up, and that's me and one of my former students, just displaying. And the projector's up high, obviously, at this point, and the telescope's on the ground, and we're running it with cords and projecting onto the ground. The next one is a view that came out of that one. I talked to Peter and I said, Peter, what would it take? We have the lunar eclipse coming up in January of 2019. What would it take to project onto the side of the museum? Because the museum, the Sam Noble Museum of Natural History at the University of Oklahoma, has a great gray wall. And what you're seeing there is the entrance to the left, and we were able to put the moon up. We also had probably about 15 scopes set off on the side of the museum there. So people could kind of float from, this is pre-COVID, could float from one to the other. All the local astronomy groups and anyone who is a Norman person, a Norman resident, probably came out to something like this. We advertised through the, it was through the school. The schools put out what they call Thursday folders, and the kids get all sorts of information at that point. The Girl Scout Astronomy Club, definitely they had just constructed their first telescope and their 8-inch Dob, and so they were part of this, and it was a great night. But let me show you what we were able to show. And this was sort of again, January of 2019, way before we were thinking about in terms of COVID. And so you can see the moon close to totality, and we got a picture. More people were at this point staring at the museum wall than they were looking through telescopes. And so this eventually gave us the idea that this was one of the safe ways we could distance people when we had to. How about the next slide and see what we have? Okay. So last December, confronted with COVID and last fall, Norman schools were virtual 2 weeks. We were hybrid 2 weeks, and then we went back virtual. And from October 12th on, we were in person all year. Fortunately, I had a site administration that kept us very, very safe. And they allowed us to have observations at our local elementary school that's about 4 miles outside of Norman in fairly dark skies, not pristine. We have light pollution around us, but it's to the east of the town. And so we always have, with the star party, we said, we want to do this for the Great Conjunction. And we said masking would be required. So we had about 10 telescopes that were willing to come that night. And we set them up about, instead of 6 feet apart, we went 10 to 12. And I think you have to decide on your local, what kind of community spread there is as to how far apart you would put them. And we lined all these scopes up on the west side of the school. We noticed that people generally came in family groups or groups of friends who had been traveling together. So we definitely kept these groups 6 to 10 feet apart. And then we used the video setup to project the skies on the wall. We also had Lysol wipes handy that we could wash off any of the focusing mechanisms and things like that on the scope. So let me show you what we were able to do. We again had a great wall. And so what you're seeing to the left is actually Saturn and Jupiter and Saturn. And on the right, we had another setup because Mr. Mark Klein came. We have a very active radio club in the area. And these are the people who usually know all the electronics and are willing to troubleshoot and do things like that with us. Ladies, could you please close the door? I'm on a Zoom. Okay, thank you. I'm sorry, there's a lot of people running around here. And so we put the moon up here and then we had the conjunction and people absolutely loved it. How about the next slide? You can see how close it went. And here we had one of our physics teacher and his young son, William, and William just took the spotlight and did the dancing and everything in front because he's seen us do it on the ground. So instead of the ground, we went to the outside. We went up. And how about the next slide? This past week, I have been at the Okie-Tex Star Party. And this is last year, obviously, our Okie-Tex Star Party was canceled because of COVID. This year, we went ahead and held it. We had obviously fewer people because of COVID, but it was still extremely successful. We had clear skies most nights, and the nights it wasn't clear, it would usually clear for whole sections of the night. The focus on COVID, if you're outside, you have to be, if you're indoors, you definitely had to be masked, but outside, it went with a pick 2. You were outside, you were 6 feet apart, or you were masked. So pick 2 of those. And that was a very, very helpful, I think most of us felt safe. There were a lot of people who didn't attend the talks inside because they didn't want to be inside. A lot of people grabbed their food, ate outside. But it was an extremely successful star party. And my students from Norman North came with the new teacher and I helped them, do the same thing. And the kids were very good about masking and they know it's a privilege of what we're doing. So we tried different ways. We're looking at International Observe the Moon Night next week. If we have good weather, I know OKC will probably set up this year at Windsurfers Point. And they've already started publicizing in the papers, but the idea is even if you're outside, the observers prefer you come along and be masked. If not, we'll have masks handy and to offer to people and to be polite. But that's kind of the bottom line, that since we are a private group, we want to play things safely. So if you have any questions on the technology, it takes a little longer to do something like that. But these are the glorious skies. Go to the next slide. And this photo is by one of our astrophotographers in the club, Chris Scott. And this is the way the Mesa country looks like under red light conditions. And this was obviously a long, photo, time-lapse photo. So if you have questions, please, please, please feel free to ask. And I live in Oklahoma, and my governor does not want to mask mandate. So I think individuals and private groups have to take things into their own hands. And we want to do it safely. We want to go observing, but we want to take it safely. And I felt last year safe, but this year there's no mask mandate in the schools, and I'm glad I'm retired. So
huge props to all the teachers who taught in these past few years. Thank you so much, Eileen. Those pictures are amazing. Thank you. Thank you for sharing all of your great ideas. I hope you all have a really, really safe International Observe the Moon night, and whatever that looks like for you. Thank you. I really appreciate it. And have a great night with the Girl Scouts. Yeah. We're going to take a really quick break. We're running a little behind, so we're just going to share a bit of music with you, and we'll be back in a couple of minutes. Thank you all for tuning in from everywhere. Take good care. We'll be right back. Huge thanks to WindSync, who just performed Luna Nova. That was a piece composed for the moon by Mark Miletus, and the video artist for that was Robin P. Gold. We thank you all so much. We'll share the link to those in the chat. There are quite a few, and you'll be hearing a few more tonight. Thank you for that. I wanted to also encourage anyone who wants to join an International Observe the Moon Night event, that there are quite a few going on, both virtual and in person. So make sure to check out the link to the events page on the International Observe the Moon Night, and we'll put that up in the chat if we haven't already. Thanks to everyone. Kayla, would you like to start the next hour off?
Absolutely, yes. Wow, so let's keep cruising right along here with a huge thanks to everyone joining us from all over the world and all different time zones in the first hour of our program. We're going to welcome now Marilé Colón Robles, and Marilé is the principal investigator for NASA's Globe Cloud Gaze program, as well as wearing other very exciting hats, and she's going to share with you a little bit about how you can get involved with NASA science. So welcome, Marilé. Thank you for being here.
Thank you so much. I'm really excited to be with all of you today. I'm going to be talking a little bit about citizen science and observations and clouds. I know clouds are not always our best friends, but we need them. They make our nights warm. And there are other things that maybe you can do when you do have clouds. So a little bit about me. I'm from San Juan, Puerto Rico. That's why my name sounds a little bit different. And yes, I got to go to the Arecibo Observatory before it broke down sadly last year, but that inspired me to study nature. Even though I am an atmospheric scientist, I'm also a backyard astronomer, and that's a picture of me last year looking at the conjunction. And I've had the unique opportunity of being with the moon rocks collected by the Apollo mission. So I'm really excited for International Observe the Moon Night. I play sports as well, and I've met a lot of people playing sports at NASA. That's my NASA volleyball team, and we still play in COVID times. We just look for a space outside, and I love music, so I really enjoyed that piece that we just heard before I started. Now, not all clouds are created equal, and usually around this time of the year, we get some altocumulus clouds and stratus type clouds. We also get these thin, wispy clouds, which we call cirrus clouds. And I think once you've noticed that not all clouds are created equal, Thank you so much for that. Here's a picture of the moon I took about a week ago, and you notice these puffy clouds and you notice a ring around it. Those are altocumulus clouds, which kind of make it a little bit spooky for this time of the year, which is really exciting. But the color also tells you what is inside of those clouds. Clouds can be composed of water droplets, ice crystals, or both. But when they're ice crystals, you get some beautiful things happening with the moon's reflection of the sunlight. So the thickness of those ice clouds will result in halos or coronas, like I have here some examples here. Also, if there's just ice crystals in the air and they hit that moonlight just in the right spot, you get some really spectacular moon halos and moon coronas and things like that. So cold is the season for seeing all these spectacular things. And also, sadly, sometimes it does rain when you want to see the moon, like tonight here where I'm at in Virginia. But that's okay. Rain is important. We do need rain. And not everybody knows that there's only 2 clouds. I said it again. 2 clouds that produce rain. There's only 2. Cumulonimbus, which is my favorite, thunderstorms, and then nimbostratus clouds. Now, when you're setting up, like I've done with my family, there's my husband and my daughter setting up for that conjunction picture that we took. It's a great time to make some cloud observations. One of the things that we were running was the solar Terminator problem. And it's a problem when you're trying to study clouds. The solar Terminator is that line between the sunlit side of the Earth and the dark side of the Earth. And when you're using satellites to study clouds, some types of clouds kind of like disappear as you transition from looking at the sunlight being reflected from clouds and looking now at infrared images of the clouds. So we call it the solar Terminator problem. That's a great time to make some cloud observations. Now remember also that the moon is out during the day as well, particularly during solar eclipses. And so you can also make cloud, temperature, and other observations with the GLOBE program. And there's my daughter and her friend looking at the solar eclipse in 2017. With their NASA goggles. Now, what is the GLOBE program? GLOBE stands for Global Learning and Observations to Benefit the Environment. It's NASA's largest and longest lasting citizen science program about the Earth. Now, citizen science means that you make observations even though you're not a scientist or an expert in the field. And then us researchers who are studying this use your observations in our studies. And so the GLOBE program started in 1995 when teachers, students, and scientists came together on ways to use observations and collect observations for research purposes. And here's a picture of our last face-to-face meeting with all the students from around the world, because GLOBE is represented by 126 different countries. And here are all the students that were present in our last face-to-face annual meeting. So we would love to have your observations through the GLOBE program, particularly of clouds, because I'll get to see them. Now we engage with different communities, and yes, we have recursos en español, así que si hablas español, or do you speak other languages? I just said that there's resources in Spanish, but because we are an international community, we have resources in 6 different languages. We have resources for teachers, for educators, after school programs, lifelong learners, families, and communities. So what we do is that for your cloud observations, the team here at NASA Langley Research Center in Hampton, Virginia, matches them to satellite data. And then you get a NASA personalized email with your observations matched to satellite data. Pretty cool, right? It's really simple to use the app. You can just download it for free. It'll ask you for cloud cover, sky conditions, if you're seeing dust storms or smoke plumes. And then the coolest part is to take photographs. It's really neat. So you can download it for free. You can reach us in multiple ways. And we hope to get your observations of clouds either during the day or as you're setting up for night observations. And don't forget, citizen science is for everybody. Visit NASA's Citizen Science webpage to find out more about different programs, about the Earth, the solar system, the universe, the sun, all different types. So thank you so much for having me today.
Oh, Marilé, that was wonderful. Thank you so much. It's great to hear. So you've made cloud look much less intimidating. Thanks. Even if you get clouded out for International Observer the Moon Night, there are still ways to participate in science. So I hope you all download that app and get observing whatever you happen to have in your skies. Thank you.
Yes, thank you, Marilé. We get really excited about observing the moon around International Observer the Moon Night each year, but this is a jumping off point. We hope that you, like us, will feel excited to observe all kinds of things in the universe around us, not just on October 16th, 2021, but throughout the year. And this is just one great way to do that. Next, we are going to welcome Brandon Rodriguez, who is a guest from the Jet Propulsion Laboratories education team. Brandon is an education specialist. I've had the privilege and the opportunity to be in one of his education workshops, and it was just great. I'm so excited you're here with us today, Brandon. I'll turn it over to you.
Yeah, awesome. Thanks so much. So good to see you again. It's been like way too long, too many years. Why did you leave California? We miss you. My name is Brandon Rodriguez. I work at NASA's Jet Propulsion Laboratory in Los Angeles, California. Super excited to be here. I have been just kind of listening over here on the side, and I think it's really exciting how many people kind of have this union of the science that's being done, and then just kind of the awe and the wonder of just looking at the images. We saw these awesome pictures earlier of the moon around Rome, and it was beautiful. And I think it's really cool to, at the same time, think that there's still science to be done. And I think that's why I'm so excited about this idea of International Observer the Moon Night, as well as being able to speak to you guys today. So I, just as a very quick background, have the most lucky position in the world because I get to be a scientist and a teacher. So I still teach high school physics, which is crazy to me. But I work at NASA as well. And I get to work with teachers and students all over the world and kind of bring cool activities and resources to them. So I wanted to show you guys a few of those. And I thought in the theme of everything that we're doing today, maybe I could share my screen really quick and tell you that, in fact, earlier this year, I was very much observing the moon, and I was observing it from the most wild place on the Sophia Observatory. So Sophia, as you can see here, looks like a normal plane that you might take to travel. But as you can see in the middle, there is actually a door that opens, and a 3-meter telescope is actually observing out as you're flying, which is just insane. Think about how incredibly specific every motion needs to be able to make sure that you are looking at something like the moon without rocking around and being able to collect images. So it's a really, really amazing high-tech device. And we were actually observing the moon looking for water. So here are just a couple pictures. Here's me trying to look cool and being excited. And then on the right, much more nervous as we were taking off. So that was the coolness quickly subsided. But the telescope from the inside looks like this. And what you can see is that it's effectively like in a cylinder, and it rotates all the way around. So this is a giant counterweight, and you have computers everywhere, and you have these little like shock absorbers, if you will, to make sure that nothing rattles around. And we were out looking for ice in craters of the moon and found it, which is really, really exciting. So we're trying to find resources on the moon so that the moon could serve as a little bit of a gateway, of a jump off point. If we ever want to really explore the solar system, like perhaps to Mars or beyond, we need to have a means of a nice low gravity base in space for those operations to take place. And that means resources. So as you guys kind of, to the students watching, get a chance to explore the moon, remember again that we explore it both because it's beautiful and exciting, but we also explore it scientifically as well. So I actually had some students prepare this project. These are some middle school kids that kind of made a cool moon crater project. And I encourage you guys to do the same. What they were doing was they just made a little, baking sheet with flour and cocoa and sprinkles and stuff like that to simulate the moon. And then they asked, well, are craters always round, or how deep do they go? How steep is the angle? So what they did is they took different rocks, different shaped rocks, and they kind of dropped them onto the moon. They had these asteroid impacts on the moon from different angles and different strengths. And they just kind of observed to see what kind of impacts you get. Wow. Pretty neat. So, again, you'll see them kind of go through different angles and play with different rock sizes. And this is a good way to kind of simulate the multi-billion year history of the moon to get a feel for why is it shaped this way? Why are there these deep craters? And why do they still have water in them? Thank goodness, because we're going to need it if we're ever going to build a lunar base. I'll point out that, again, the moon itself is not where we want to stop, right? We want to explore further. And we do that with very cool robotic scientific equipment like this guy here out of my lab, the Perseverance rover, which landed on Mars just earlier this year in February. And here is its twin. This is the engineering model, which we still do driving tests on, as we're kind of just operating a nice stationary turn. And I'll even point out to you guys, just to get a feel, even though you can see some of my colleagues in the back, just so you can see just how big this is, I brought you a wheel. So this is one of the wheels of the rover. So just for a picture of scale, 6 of these, about half the size of me, aluminum on the outside, titanium on the inside, and about 40 pounds. So that's my exercise for the day for sure. So again, if we ever want to explore the moon further with rovers, or we want to explore more of Mars with rovers, or places like Titan and Enceladus, all these other moons. Don't forget, there are so many other very exciting moons in our solar system that I very much want to observe. I would love to send some missions to. And that's really some of the cool science that JPL is doing, is exploring moons of Saturn and Jupiter, and these places that have water or volcanoes and so much exciting geology. So I'm excited for you guys. Observe the moon that you can see, and then go and get an awesome degree in science and start observing the moons even further away, because I think that's where the real excitement starts. So the last thing I'll say, since I'm almost out of time, is you can find so many activities at this website. This is the website that my colleagues and I maintain, full of activities for teachers. If you click up here on this teach section, you're going to see like lesson planned activities already on PDF, already have answer keys and assessments, and everything's just already made for you so that you're ready to deliver it to your students. But to kids out there, if you want to explore this learn section right here, this is where you'll see activities like that, moon craters. I was just doing one last night with some students where we are making little rubber band powered rovers. So it's kind of like an old Hot Wheels car, if you remember, and it's got a rubber band and you can wind it up and let it drive off. So we were trying to race to see who could make the best rover drive across the backyard. So again, so many cool opportunities, and I encourage you guys to be in awe of the moon. It's beautiful and amazing, but think about it not just from the beauty of it, but from the scientific promise of it as well. I think it's going to be really, really exciting as you guys get older and come work at NASA with people like me and Marilé, and we're waiting for you guys to have cool careers alongside us. So thank you guys so much. I really appreciate your time.
Thank you, Brandon. That is great. There are so many great resources right there on that website. We use it all the time. It's really fun to be able to get out and start doing public engagement again. I'm so excited. Thanks for joining us. That's great. All right, up next, we have a whole team from the Lunar and Planetary Institute. I want to introduce the manager for Education and Public Engagement, Christine Schupla, who's here. Hi, Christine.
Hey, everyone.
There's
so
also
glad to be part of this.
Oh, we're so glad to have you. Thank you. Sherelle Webb is joining us as the public engagement lead, and also Yolanda Ballard is here as the program coordinator, and they have some great, hey, keep your eyes on the road. We've got you here. We have a great video from this team, and I think if Scott, if you can pull that one up, we will kick us off with that and then hear from them.
Absolutely. Let's go ahead and get started. The activity that you're about to see is called Splat, and let's share with you a little bit about the activity.
Okay, I think I have it. So,
hi, I'm Katrina Clipper.
Hi, my name is Cameron Hill.
Hi, my name is Gwen Foster, and this is my daughter.
Hi, I'm Elle.
Thank you all so much. All right, so we're starting with our Splat activity. Please go ahead and hold up the water balloons so we can see your water balloons. Yeah. Can any of you tell me how wide are your water balloons? How big are they?
5 inches.
5 inches.
7 inches.
Awesome. So we've got a 5-inch water balloon and a 7-inch water balloon. Okay, whenever you are ready, let's start by on the count of, why don't we do a countdown? Why don't we do a countdown for 5 seconds before we throw our water balloon?
Yeah.
Okay, here we go. 5,
4, 3, 2, 1.
Everybody throw your water balloon.
You got to drop it hard. Pick it up and throw it hard.
Sometimes it takes a few times for it to break.
All right. So now let's take a look at the splat. Can you all show me how big your splats are on the ground? How big are the splats?
Wow.
How wide are your splats? Does anybody want to estimate how wide your splats are?
Big.
Big.
Mine big. Real.
Is it a lot bigger than 5 inches to 7 inches? Any idea how many times bigger it is than the 5 inches or 7 inches?
3.
3 times bigger? Okay.
How many times bigger is this flat than the balloon?
10 times. 10 times bigger than for mine.
About 10 times bigger. Okay, so at least 3 and maybe as much as 10 times bigger. When an asteroid hits the moon or Mars or another planet, do you think the asteroid just sits there on the ground, or do you think it breaks up into pieces like your water balloon did?
Break up.
Absolutely, it breaks up into pieces. And do you think that the hole that it makes in the ground is the same size as the asteroid, or do you think it might be a lot bigger than the asteroid?
A lot bigger.
You're exactly right. You're exactly right. Any final thoughts?
What?
Y'all did a great job. Thank you so much. Let's see everybody's wonderful faces one last time. Did you have
So-
fun throwing that water balloon?
This is a really fun activity that you can do with kids and with adults. Who doesn't like water balloons, right? You just need an outside space or maybe a patio space. But the idea here is you can do this activity maybe with the activity that we just saw, right? We just saw an activity with crater boxes where you're dropping materials into a box. But in addition to that, this activity shows a different aspect of the model of craters. So we are seeing a little bit more about craters and how they work this way. We're finding out that you can, when you have an impact, initially they weren't really sure what was happening, right? They thought that maybe the impact would cause parts of the asteroid to be left there. And that's why they mined out meteor craters so extensively. They were looking for pieces of an asteroid, but in fact, it gets destroyed largely, it gets vaporized. You get a few pieces here and there, but it's largely destroyed. So unlike the first activity where you get to see features of a crater quite nicely, in this activity, you don't see many of the features of the crater, but you see that the impactor, the asteroid or the comet that ran into the moon, that runs into other planets, is destroyed. And you also get to measure the dimensions, and you can do it with lots of water balloons and take multiple examples here. It should be about 10 times wider, ideally. So. Yes, thank you, Marilé. I like both of these activities very much. They're fun to do together. We've got a few minutes, and we thought we'd spend just a few minutes talking about craters on the moon. And so let's go ahead and show you some pictures here. Orientale Basin, of course, is a type of crater that's very large, and it has multiple rings around it, you can see. So some craters, some of the biggest ones, have multiple rings, and Orientale and many of the largest ones have since been flooded in with basalt lava after the initial impact formed those nice round features that we see for the Sea of Tranquility and things like that. But in addition to that, there's other types of craters as well. There's some that are smaller. Often the ones that are really bright tend to be the ones that are the newest ones, because over time on the moon gets darker because of interaction with particles from the sun. So the really bright ones tend to be the youngest ones. Some of them are complex where they have those mountains in the middle. And these craters also are revealing things about the moon and about its structure and what lies underneath. And so each crater tells us more about the moon, about the composition, about what's happened. We can use these craters and study the fingerprints of spectroscopy to tell us more about the composition at the top and the bottom and anything that's been excavated and thrown out. We have scientists who've been studying the moon, studying impacts, studying craters all over the place. And we wanted to let you know a little bit more about this. So we're happy to have any questions from you. We also wanted to let you know where you can find these. The splat activity with the balloon exploding is at LPI's website. There's also lots more information about impact craters. And we hope that you'll consider doing some of these with your family and friends and with your audiences if you're doing programs for International Observe the Moon Night. Easy, doesn't use a whole lot of materials. So I'm going to stop sharing for just a couple of seconds and see if we have any questions or comments. And Vivian, do you have anything that you want to add? Sherelle, Yolanda, do either of you have anything you want to add?
I was just going to say, we put those links in the chat, so you should see them coming up. Thank you so much, Christine. They look like they were having such a good time. Water balloons are such a treat, especially in the evening when it's been a hot day.
Exactly. So much fun to do. And thank you, Sherelle, for helping us to connect with these wonderful families who recorded this with us this week so that we'd have it for tonight.
And thank you so much for joining us, even on a Saturday. It's great to see you.
Great to see you all as well. Happy Global Moon Party.
Yeah.
Party on.
Thanks, Christine. We will feel free to pass notes on in the chat. And if you have any questions, that's a great place to put them. Thank you all so much. That's awesome. Next up, we have a really lovely guest. We've got Dr. John Baubert joining us from Slooh.org. And we have two really cool videos from him. First is an introduction to a really lovely teachers program that they have. And I'll actually just let him introduce himself and tell you all about that. Welcome, John.
Thank you so much, Vivian, for having me on during this Global Moon Party. I'm so happy to be here and talking with everybody and celebrating the nearest celestial neighbor to us.
I think the moon is how a lot of us got hooked. I love hearing that from Gianluca earlier. Scott, I think we've got a video lined up to go here. All right, let's see about that.
Greetings! Are you excited for tonight's 2021 International Observe the Moon Night Kickoff Party? I sure am. My name is Dr. John H. Baubert, and I'm the Director of Curriculum at Slooh, a vibrant community of students, educators, and astronomers sharing their knowledge and discoveries of the universe using an arsenal of powerful robotic telescopes at premier observatories in both hemispheres. Slooh provides a direct means for students to connect with the universe and fosters a spirit of collaborative citizen science from the next generation. Now, I'm speaking to you all from Las Vegas, Nevada, but tonight you will be enjoying the views of the young crescent moon from our flagship observatory in the Institute of Astrophysics of the Canary Islands, located on the island of Tenerife off the northwestern coast of Africa. We are currently looking through Slooh's Canary 2 ultra-wide field telescope. Just to let you know, Slooh's southern observatory hemisphere is in La Dehesa, Chile, in association with the Catholic University of Chile. I also want to give a shout out to anybody who knows a teacher or educator, or knows a parent who has a child at school, basically anybody in education. If you know anybody in education or are related to somebody who knows somebody in education, please hop on over to Slooh.org. Slooh.org has free student accounts for classrooms in light polluted areas, ready and waiting to connect your students with the stars. This grant aims to help 1 million students nationwide experience the wonder of space from their classrooms and home computers. Now, it's a very ambitious goal, but you know the saying, if you shoot for the moon and miss, you'll land among the stars. You can learn more about the Slooh Space Exploration Grant at Slooh.org. Slooh will be back next week on NASA TV to provide live views of the moon during the International Observe the Moon Night's main event. Until then, enjoy the lunar views.
Hey, John, thank you so much. That's a good reminder that next week on NASA TV will be on International Observe the Moon Night. The 16th, we will have a live broadcast then as well. So not here, but on NASA TV. Thank you so much. What a cool program. And I'm so excited to get all the teachers looking at the moon. I also want to thank you for sharing an almost live mooncast. This was recorded just a few hours ago because the moon has set where the telescope is. It got pretty low in the sky. So that is one of the problems with starting a moon party the week before the International Observe the Moon Night. It's not ideally situated for observing, but all this week in the evening, you will have great views of the moon. Make sure to check that out. John, do you have anything else you want to say before we play the story?
No, thank you so much again for letting me come on here and talk a little bit to everybody. And I really hope that we enjoy the Inca lunar myth.
This is an amazing video that Milton Villarroel has recorded for us, and I want to share this all with you. Thank you, John, for making this happen. Scott, if you want to bring that next video up.
Hello, Dr. John Baubert from Slooh again. Next, an educator and Slooh ambassador, Milton Villarreal, will share an Inca myth about our moon titled El Doloroso Amor del Zorro y la Luna Inca, or in English, The Crushing Love of the Fox and the Inca Moon. Enjoy!
¿Alguna vez se han preguntado cómo fue que la luna adquirió sus manchas oscuras? Los incas tenían su propia versión de esta historia. Uno de los mitos que rodean a la luna nos cuenta cómo fue que ésta obtuvo sus manchas oscuras. Los incas creían que Atoc, un personaje ambivalente de las historias andinas tradicionales, se enamoró de Mamaquilla, la luna, debido a su hermosura. Este personaje toma la forma del zorro andino. En su forma antropomorfa o humana, Atoc juega dos papeles. A menudo es un personaje muy querido que utiliza sus habilidades para convencer a los demás de hacer lo que él quiere. Otras veces puede ser muy engañoso y vil por conveniencia propia. A veces el zorro es un ladrón, pero también se lo ve como inteligente y sagaz, como las características atribuidas a los zorros en otras partes del mundo. La historia prosigue diciendo que Atoc utilizó todos sus encantos para seducir a la bella Mamaquilla, pero la diosa permanecía siempre esquiva y sin importar lo que hacía el zorro, ella mantenía una distancia prudente. El zorro persistió, y fue esa persistencia la que finalmente ayudó a Atoc a lograr su cometido. Atoc había encontrado la forma de subir hasta las alturas donde residía Mamaquilla. Ella premió los esfuerzos de su galán y decidió aceptar su cortejo, pero cuando el zorro se elevó a los cielos para estar con su amada, ella lo apretó tan fuerte contra su pecho que sofocó a su admirador. Como resultado de esto, su perfectamente blanca vestidura quedó manchada por los restos de Atoc, produciendo las manchas oscuras que vemos en la superficie de la luna hoy en día. La moraleja de esta historia sugiere fuertemente que seamos cautos cuando nos aproximemos a un dios o una diosa, porque sus poderes son muy superiores a los nuestros, aún en las situaciones más románticas.
Wow, thank you so much, Milton. Educators, Slooh.org has free student accounts for classrooms in light-polluted areas to connect your students with the stars, ready and waiting for you.
So beautiful.
Thanks for having
Thank you, John, so much. That is beautiful.
Oh, you're welcome. I hope we really enjoyed that myth. I can tell you every time I look at the moon after putting this together, I can see Atoc up there.
And thanks to Milton, I see you're joining us online. I appreciate that story so much. It was really beautiful. All right. Thank you. I hope you all have a wonderful time observing this week. Scott, I think I'm turning it over to you. Is that true?
I think you are. Okay, so we'll start this video with Amy Kaminsky.
Hi, Scott. Thanks for having me today. My name is Amy Kaminsky, and I lead NASA's public prize competitions, challenges, and crowdsourcing efforts, where we look for people outside of NASA to help us solve our toughest challenges with out-of-the-box solutions. I'm really excited to talk with you about how you can get involved in NASA's missions. We conduct public prize competitions and challenges at NASA to bring forward unique solutions and to diversify participation as we look for clever ways to explore the solar system, sustain human space travelers, build more robust aircraft, and more. We value the different perspectives that can be brought to bear on these NASA undertakings by companies outside of the aerospace industry and by people everywhere. Our work creates solutions to problems and brings visibility to our participants, often leading to investments from outside and supporting the growth of markets beyond aerospace. We've run hundreds of challenges to date, and thousands of people worldwide have been able to participate. Our challenges are open to teams and individuals, and we offer cash prizes that vary in size, along with non-cash awards and benefits. Right now, we have several moon-related competitions open that will benefit the Artemis program that you can participate in or follow along with. The Big Idea Challenge invites student teams to develop robots that don't move with wheels. We're looking for robots that can hop, float, or fly. Up to 8 teams will win development awards of up to $180,000. 2 other student challenges are coming up in just a few weeks, Lunobotics and Lunobotics Jr. Both are looking at excavating on the moon and challenging students to design unique concepts for excavators that can operate in lunar gravity. In this challenge, college students can win scholarship money, while grade school students could win an opportunity to meet with the director of NASA's Kennedy Space Center. We're also planning the next phases of our Watts on the Moon Challenge and our Break the Ice Lunar Challenge. In Watts on the Moon, we're looking for teams to demonstrate energy distribution, management, and storage technologies for upcoming lunar missions. $4.5 million in awards are on the line. In the Break the Ice Challenge, we're again looking at excavating on the moon. We are asking teams to demonstrate their approaches for digging up icy regolith and delivering resources to a central location. There are many other competitions in planning right now, and we're looking for your participation. If you are looking for a way to get involved and contribute to the exciting work happening at NASA, this is your ticket. If you're interested, keep an eye on nasa.gov/solve, SOLVE, where we post all of our competitions and crowdsourcing opportunities. Thank you so much for having me, and enjoy celebrating Observe the Moon Night.
Thanks, Amy. It was really lovely for her to have a chance to share that with us. She is works with NASA Artemis prizes, challenges, and crowdsourcing programs. And there are so many ways to get involved observing the moon and thinking of wonderful creative ways to explore space. So I really appreciate that. I want to introduce 2 of my favorite humans on Earth and who have some really cool other ways to observe the moon and do some science with that. From the Astronomical League, we've got Aaron Clevelandson, who's joining us from Texas.
Yes, Houston, Texas.
Houston, Texas, thank you. And John Goss as well. These are 2 gentlemen who have been instrumental in some of these observing programs, and they have one that they'd like to share with you tonight. So I'll let you all take it away. Thanks for joining.
Well, thank you very much, Vivian. And I'm going to let John take the stage in a little bit, but I want to start out by sharing our screen. Maybe. There we go. So yes, we are from the Astronomical League, and we have actually more than one observing program we'd like to share with you tonight. So first, let me tell you a little bit about us. I'm an observing program director with the Astronomical League and also a program coordinator for some of our observing programs. John Goss, who's the other person with me tonight, is a past president of the Astronomical League, and he also is a program coordinator. And more on the programs in a little bit. So roughly what I want to look at is a little advice for observing the moon. Then we'll discuss the Observe the Moon Night, and then we're going to discuss the Astronomical League observing programs related to the moon, because there are a number of programs that are available. So John, let me pass it off to you. Oh, wait, let me do one more slide first. The question I wanted to address was why the moon? Yeah, we've heard lots of wonderful things tonight about all the really cool things you can do with the moon and how wonderful it really is to observe. But from my perspective, the reason we want to look at the moon is it's our nearest celestial neighbor. Everybody else is a good bit further away, and it's available and easy to observe every month. It's always there, and if you miss something this month, you can catch it next month. And the really cool thing is it's easily visible with just your eyes. You don't have to have binoculars or a telescope, which means anybody can do it any night the moon is up when the weather cooperates. So now to you, John.
All righty, thank you, Aaron. Before I talk about the Bottle Cap Projector, I'd like to say a few more words about the moon and the observing programs. You know, we have a rather select exclusive group of people who have walked on the moon. About 12 people have done that. We have about 24 people who have orbited the moon. Now, with the Astronomical League has a number of observing programs focused on the moon, and really the whole purpose of that is to enable people for themselves to go to the moon by using their telescopes. Once they complete these programs, they will have seen many of the same sites that the astronauts have seen. They will have seen craters large and small, vast basaltic plains. They will have seen mountains. They will have seen rills. They will have seen volcanic domes and so on. Many, many, many things. If you use your telescope, you can see these things too. So enough preaching right now to talk about what we call here the bottle cap projector. I got this information really from Fred Schaaf back in about the year 2000. He was discussing this, and then Guy Otwell picked it up in his astronomical calendar. Very simple concept of what to do here. If you drill a hole in an opaque object, such as a bottle cap, a hole of 16th inch diameter, look at that, hold that up to your eye and look at the moon. Look at a full moon. Because this hole is only about 1/16 of an inch in diameter, it cuts down the light dramatically. I think about only 4% of the light is let through that would normally enter your eye's pupil. So that means the glare from the bright full moon is cut down substantially. But even more important, or just as important, the only light that's let into your eye is it goes through the center portion of your eye, where most of your optical defects in your vision don't lie. Astigmatism generally lies around the outside portion of your eye, for instance. So your visual acuity will be increased substantially. So believe it or not, strangely enough, that if you take a bottle cap like this with that 16th of an inch hole, 16th of an inch hole in it, and point it towards the moon, hold it up to your eye and point it towards the moon, you will see a greatly reduced moon. There will be hardly any glare in it. Your visual acuity will be substantial. So you'll be able to easily see the various Maria on the moon. For a quick project though, you could draw the moon as you see it with the Mare Crisium off on the eastern side of the moon. Come back a week later or the next month or so, and you do it again, and you will see that the gap between the eastern edge of the Mare and the limb of the moon will have changed a little bit. So you will be seeing the effects of lunar libration just by using this so-called bottle cap projector. It's really easy to do. You don't want to have anything really smaller than 1/16 of an inch. If you go down to a 32nd, the moon just becomes way, way too dim. If you go up to an 1/8 of an inch or so, you will be letting in more light, obviously, but also more light in the outer portion of your eye, and your acuity will drop considerably. So 1/16 seems to be the sweet spot for this project, and anybody can do it. So the next time that you're out there in the full, it doesn't have to be full moon, but it has to be a bright moon, try this, and that is really cool. Now, on the next slide, which hopefully Aaron will click for me, thank you. I have a little story to tell, which I think a lot of seasoned amateur astronomers, as well as beginning amateur astronomers, can relate to. You know, you're out there with some friends at somebody else's house. You don't have your own telescope. They have a telescope that they haven't used for quite a while. It's in the closet. So that, and the moon is out, and they want to look at the moon. Since you're the astronomer, they're really kind of looking at you to do this. So they get the telescope out, set it up. It may have a finder scope on it, may not. If it does have a finder, perhaps it's way out of whack as far as alignment goes. So you're expected to find the moon. Now, if you have never found the moon before with a telescope, let me assure you, it's not a snap. It's not easy to do. You just don't point your telescope and you got the moon. The moon is only, what, half a degree in size, pretty small, really. Pretty small area of the sky. So it's hard to point your telescope initially right at the moon. But an easy way of doing this, because remember, all your friends are standing there looking at you. You're the astronomer, you know what to do, and you're looking like an idiot because you can't find the moon. Well, I mean, the moon's the brightest thing in the sky. How can you not find it? Well, you get behind the telescope, point it up to the moon to where you think it should be. You might be really lucky and the moon might be in your field of view of the eyepiece, but probably it's not. Easy thing to do is take out the eyepiece, look down the focuser tube, try to center your eye in the focuser tube. And when you look down at if it's a reflecting telescope, at the mirror, at the primary mirror, you'll see the glow of the moon someplace. And just move the telescope left or right, up or down, so to place the glow, the bright glow of the moon close to that second reflection that you're going to be seeing. Then all you got to do is put the eyepiece back in, and there's the moon. So instead of taking 5 minutes of excuses and kind of embarrassment before you zero in on this thing, well, you can do it within 15 seconds, and your reputation is maintained. So that's something to think about. Try it next time. You don't even have to have friends around you. Try it in the privacy of your own home. Set your telescope outside and try to do it like this. You can also do it for finding Venus or Jupiter, something that's fairly bright in the sky, something that you can see down through your focuser tube onto your primary mirror and be able to zero it in that way. So go ahead and try that. That's what I got. We're from the Astronomical League, and we just want to make astronomy more accessible to people and give them some satisfaction of finding it. And you don't get much satisfaction if all your friends are kind of laughing behind your back when you can't find the moon. So this will help things out, believe me. So thank you for your time and listening to that. That's what I have.
Okay, thank you, John. I have a few more things I need to cover. I see we're already out of time, so I'm going to talk fairly quickly to try to get these points across. The first thing we want to talk about is joining the party. So we do have Observe the Moon Night coming up, and we want to encourage people to go out there and actually observe the moon from all around the world. Of course, it is on the 16th. Host an event or just personally observe whatever is important to you. And working in conjunction with the International Observe the Moon Night team, we have put together a certificate, which is available for download. So if you go out and observe, print yourself a certificate, put your name on it, and relish in the joy of what you did, how wonderful it was. If you happen to be lucky enough to be hosting an event, even if it's for just your family or perhaps the neighborhood, then we encourage you to get a download of the certificate as well and go ahead and print copies out for them as well. So there's the website. It's the Astronomical League version, but that's the website where the certificate's available for download. This is what the certificate looks like. I'm just going to skip over that because I'm really out of time. But we also have a second option. So in the past, the Astronomical League has worked with NASA to come up with something we call NASA Observing Challenges. And we have done that again for this one, International Observe the Moon Night. So there are some requirements, but it is open to all. You do not have to be a member of the Astronomical League to participate. So you observe the moon, and we give you about a week to do it. The reason you can't start before the 15th is some of the features we want you to find aren't available until you get a fairly good gibbous moon. So you do have to wait till the 15th, which of course is the day before. But then you can go for about a week after that and still get all the features that you need to get. Sketch what you see with just your eyes. Do an outreach activity. So this does not necessarily mean an outreach event where you've got people looking through telescopes, but do something to share the excitement of observing the moon with other people. So do that activity and then submit your information to the coordinator. And we do have a deadline. So by November 22nd, I am the coordinator. So my information is on this website. But if you want more information on that at the Astronomical League website, just check it out, and it tells you everything I'm going to tell you, but in a much more at your own pace. So what do we want you to look at? We have a list of more than 10 items, and the requirement is you have to identify 10 of these in your sketch. So a bunch of them are because that's the big dark spots. They're very easy to see. But in addition to that, there's a couple craters that are visible. The crater rays from Crater Copernicus are also visible, and the woman in the moon. So we heard about the fox in the moon, and had I known we were going to have that story, I probably would have chosen the fox in the moon instead, because that's new to me. But the woman in the moon is actually very easy, and I think really looks like a woman in the moon. So this is a picture of the moon, and this is a picture of the woman in the moon. complete with her pigtails. You can see her eye, her nose, her mouth, and her chin. So I encourage you all to go out and try to find the woman in the moon. Want to spend also a very brief moment here talking about the observing programs at the Astronomical League. So for most of the programs, you do need to be a member, either through a local astronomy club or as a member at large. And we have close to 75 or so observing programs that cover everything from soup to nuts. However, there are 4 that are very specific related to the moon. So I wanted to just mention those in passing. We have a lunar observing program. It involves 100 features. It does require a telescope, and it requires you to observe throughout a month or multiple months if it takes you that long because of weather. We also have a binocular lunar observing certificate that is a subset of that observing program. In addition to that, we have a Lunar 2 observing program, which is designed to make it a little more challenging for you. So you have to actually time things, you have to plan observations. Most of them are paired. So you do one when you get a long shadow, and then you also do one with a very short or no shadow to see the difference in what the features look like. And then the last one, our newest lunar program, is Lunar Evolution Observing. And the neat thing is, just like the Earth, the moon has gone through different phases in its history. And you can actually pick out details and tell what part of that history they belong to based on what they look like and how they interact with other features. So I'm going to stop there. I do have one more slide. I'm only going to show it to you because I know we don't really have time for questions, but I wanted to have everybody look at my question mark, because I thought it was cool.
Very nice.
Okay, so back to you, Vivian.
Aaron and John, that's great. I had no idea about the looking down the eyepiece. That is a great tip. Thank you so much. And I can't wait to do the Lunar Observing Challenge this year. Very, very excited. And we'll share some slides with you at the end about some good trivia on the moon that John has shared with us. So thank you both so much. We're going to take a quick break for all of us, and we'll be back in about 5 minutes. Meanwhile, we have some great music again. Oh, this time we've got a video from Greg Varney coming up. Is that what's coming up next, Scott?
Magnificent Desolation.
Magnificent Desolation. That is it. I want to just say thanks to Jamie Dupuis, who was the original music composer for this and allowed us to use it. So thanks to both Jamie and Gary. Thanks.
And then also combined with that is another performance from WinSync, Debbie Waltzing on the Moon.
Wonderful.
And, right?
Yeah,
So maybe a little bit longer than 5 minutes.
Okay. 7 minutes. We'll see you in 7 minutes after these.
All right. Yep.
Thanks.
right. Oh, Scott, I don't know if it's just me, but I couldn't hear you just now.
Oh, it's all you at this point,
All
Kayla.
Fabulous. Thank you so much for lining up those lovely selections and for all of the video and audio magic that has been happening so far tonight. Scott Roberts with Explore Alliance, everybody. Virtual applause. Yes. So that last piece that we just heard was Debbie Waltzing on the Moon, performed by Wind Sync, composed by Mark Mellitz, and the video artist is Robin Gold. Before that, we saw Magnificent Desolation with an original soundtrack by Jamie Dupuis and visual composition by Gary Arnie. So huge shout out and thanks to all of those artists for sharing their work with us this evening. Next up, we've got our NASA Moon Views Hour, our final hour of the program. And to get that started, I am so excited to welcome my colleague, Staci Tiedeken of NASA's Goddard Space Flight Center to provide some highlights from recent and upcoming lunar science. Over to you, Staci.
Great, awesome. There we go. All right. Hi, everyone. It's so great to be here tonight for this wonderful event. And as Kayla mentioned, my name is Staci Tiedeken, and my role for International Observe the Moon Night is that of International Partnership Coordinator, which means that I get to work with people all around the world. And for this presentation, I'm going to focus on some recent news as it relates to the moon. But because there's so much that happened, this is just a brief overview. And as well, I'm going to look at what's ahead in lunar-related topics as well. So there are a lot of things that happened this year in moon news. So this presentation is by no means a complete account. I did, however, want to bring in a more international perspective. And so we'll highlight some NASA-related moon updates, as well as news from other countries around the world. So 2021 started out with marking the 50th anniversary of Apollo 14, as well as Apollo 15 later in the year. So Apollo 14 was the third human moon landing, and with Alan Shepard and Ed Mitchell setting foot on the lunar surface on February 5th of 1971, almost 10 months after Apollo 13's intended landing date. And two highlights from this mission include Al Shepard hitting 2 golf balls on the moon at the end of the last moonwalk, and Stuart Roosa bringing hundreds of tree seeds with him to the moon, with many now growing on the Earth as moon trees. And then the 50th anniversary of Apollo 15 followed in July. This was the 4th human moon landing, and this mission saw the first flight of the Lunar Roving Vehicle, also called the Moon Buggy. And Dave Scott also demonstrated Galileo's discovery about falling objects in gravity fields when he simultaneously dropped a feather and a hammer, and they both hit the ground at the same time. So this is an especially exciting time for lunar science and exploration. NASA's Artemis program plans to land the first woman and first person of color on the moon within the coming years, and features collaborations with commercial and international partners. And this will promote equity, signaling to people around the world that they too can see themselves among the stars. And NASA's Artemis missions also include sending a suite of new science instruments and technology demonstrations to study the moon and establishing a long-term presence there. So there have been a lot of developments in the Artemis program in 2021. So be sure to check out the Artemis website for the full details, which will be included in the chat box. But I did want to just highlight one particular highlight or update, and that's the naming of the mannequin that will be launching on Artemis 1, which is NASA's uncrewed flight test of the Space Launch System rocket and Orion spacecraft around the moon later this year or early next year. So Commander Moonikin Campos is the official name of the Artemis 1 mannequin. The name Campos is a dedication to Arturo Campos, a key player in bringing Apollo 13 safely back to Earth. And there have been many developments to the Artemis program in the international realm as well. And one of these updates comes from the European Space Agency, or ESA. ESA is contributing to humankind's return to the moon with its European service modules that will be incorporated into upcoming Artemis missions. So as I mentioned, NASA will be launching Artemis 1 from Kennedy Space Center in Florida. And this uncrewed mission will carry the Orion spacecraft, which will incorporate ESA's European service module, which was built and tested by Airbus Bremen in Germany with the help of 10 European nations. And then another international development for the Artemis program comes from the Canadian Space Agency. Canadarm3 will be Canada's contribution to NASA's Gateway, which is a vital component of Artemis that will serve as a multi-purpose outpost orbiting the moon. Canadarm3's highly autonomous robotic system will use cutting-edge software to perform tests around the moon without the need for human intervention. This next generation Canadian robotic system will be designed to maintain, repair, and inspect the Gateway, capture visiting vehicles, and enable science both in lunar orbit and on the surface of the moon, among other tasks. And the Lunar Reconnaissance Orbiter is my next topic, and it's NASA's flagship mission at the moon. And I know Andrea Jones mentioned this at the beginning of the broadcast, but it's actually what helped start International Observe the Moon Night, and it's been orbiting the moon for over 10 years. LRO is building on the legacy of Apollo and is reshaping our understanding of our nearest neighbor in space. And it's helping us prepare for the next phase in human exploration of the moon through the Artemis program. Using data from LRO, Lunar Prospector, and the Moon Mineralogy Mapper instrument on board India's Chandrayaan-1 spacecraft, scientists have identified likely locations for NASA's Artemis missions to find and collect pieces of the moon's mantle. And the team of scientists generated this map that I'm showing now, which shows the thorium concentration across the vast South Pole Aitken Basin, which is on the lunar far side. And it reveals the distribution of mantle materials that were violently ejected during this basin-forming impact. High thorium areas are shown in red, with purple and gray representing lower abundances. And you can see two craters in the northwestern region of the basin that are exhibiting especially high thorium abundance. And this suggests the presence of abundant mantle materials that are currently exposed on the surface there. And these precious rocks born deep within the moon can help us understand how our moon and other rocky worlds evolved. Now let's take a look at what's coming up in lunar-related news. So NASA is currently working with several American companies to deliver science and technology to the lunar surface through the Commercial Lunar Payloads Services Initiative, also called CLPS, because we love acronyms. So this program enables the quick acquisition of lunar delivery services from companies to bring an assortment of robotic payloads to the moon's surface. The first CLPS instruments are planned for launch early next year, and I won't go through them all, but they do include payloads from Astrobotic, Intuitive Machines, Firefly Aerospace, and Maston Space Systems. So one of the CLPS missions heading to the moon is called Viper, or the Volatiles Investigating Polar Exploration Rover. Part of the Artemis program, Viper will launch in 2023 for delivery to the moon by Astrobotic's Griffin lander. Viper is NASA's first mobile robotic mission to the moon and will land near the western edge of Nobile Crater at the moon's south pole. And it will map and explore the region's surface and subsurface for water and other resources. And now moving on to some more international moon news. The Korea Pathfinder Lunar Orbiter is South Korea's first lunar mission, and it will be equipped with 5 payloads developed in Korea and 1 payload developed by NASA. It's scheduled to launch in August of 2022 with the goals of developing original lunar exploration technologies, demonstrating a space internet, and conducting scientific investigations of the lunar environment, topography, and resources. The SMART lander for Investigating Moon, or SLIM, is a Japan Aerospace Exploration Agency mission designed to demonstrate accurate lunar landing techniques by a small spacecraft. SLIM is a mission for researching the pinpoint landing technology necessary for future lunar probes and verifying this on the surface of the moon with a small-scale probe. SLIM is scheduled to launch as a ride-share payload with the X-ray imaging and spectroscopy mission in 2022 from Japan. And those are just a few of the moon updates from this year. I wanted to thank you all so much for your attention, and you can actually find an expanded version of this presentation on moon.nasa.gov at the link that will be included in the chat. So thank you.
Yes, thank you so much, Staci, for joining us with those updates. That's really exciting stuff. And like Staci said, there's much more to explore. So we'll be adding some more links in the chat as we move forward here. Next up, we are going to get to hear from someone whose real job title is visualizer, but whose job could also be described as literally transporting us to other worlds via amazing data science. And that person is Ernie Wright of NASA's Scientific Visualization Studio. So Ernie, I'll turn it over to you. Thank you for being here.
All right. I always feel bad when I make other people say Scientific Visualization Studio because it's kind of a mouthful. We always just say SVS. And Staci mentioned moon trees. There is a moon tree in front of the visitor center at Goddard, where I work. Although I haven't been there in a couple of years, visitor center has been closed for obvious reasons, and I hope it's still there. But that's kind of a cool legacy of Apollo 14. So I make pictures of the moon based on the data that we get primarily from Lunar Reconnaissance Orbiter. I've been working with LRO since it launched in 2009. And this is what it looks like in orbit. This image was actually made by my friend Chris Meany, but all the other things that you'll see are things that I made. Just to give you an idea of what LRO has been able to accomplish, it's a mapping mission. It's mapping the surface of the moon from orbit. And what I'm showing right now is a computer model of the surface of the moon based on the best information we had before LRO went there. And this is how that has changed based on data from just LRO's first 2 years. This is Schrodinger Basin, which is an impact feature near the South Pole. And something this topography allows us to do now is, in conjunction with another mission called GRAIL, map the mass distribution, the gravity beneath the surface. And this tells us something about the composition of the crust and how thick it is, and a lot of things about the energy of impacts like this. So it's a bunch of data that I get to play with all the time. One of the things I've done that some people in the audience might be familiar with is this annual moon phase and libration visualization. I happen to have here what the moon looks like right now, or maybe 15 minutes ago. And a week from now, it's going to look like this on the night of International Observe the Moon Night. This is particularly interesting to me because the libration very much favors the northeast quadrant of the moon. That's in the upper right corner of the image that you're looking at. And so you'll get a very good view of Mare Humboldtianum and some of the other features that are normally not very visible on that side, because the moon has, our view of the moon at least, has changed a little bit and allowed that edge to become a little bit more exposed. Overall, although we see the same face of the moon, we see about 59% of it, not just 50%, because of this sort of optical libration, this apparent wobbling in the moon. So one of the other things I've been able to do is map solar eclipses. This is from the total solar eclipse from 2017. And I hope some of you had an opportunity to travel to the path of totality and actually see that happen, because it was a really cool thing. I happen to be in Nebraska, but I put up Oregon here. One of the things I discovered while mapping this, and this had been found by my friend Michael Zeiler a few years earlier, is that the shape of the shadow is not a smooth oval. It's this sort of polygon shape. And I'm in the process of writing something up that will explain why that happens, but it's basically because the moon isn't a smooth sphere. The mountains and valleys in the moon either block or allow the sun to come through for just a couple more seconds, and that changes the shape of the shadow on the ground. The shadow also interacts with the terrain, and something I was able to do when I made these maps is calculate the shadows, taking into account the effect of, the Cascades and the Rockies as the shadow passed over them. It makes little ruffles in that shape. It's pretty cool. So hopefully, whether or not you were able to see the 2017 eclipse, I hope some of you are preparing to travel to see the eclipse in 2024. I'm going to be in Texas visiting with my sister, who's about 30 miles outside the path. I can't think of a more exciting, interesting thing to see as a natural phenomenon, particularly for sky watchers, a thing that happens during the day than a total solar eclipse. It's just very cool. So Staci also mentioned that we're sending both people and robots to the moon, and in particular to the South Pole. Something I just worked on was the announcement of the landing site for Viper that Staci described. And this is a still from an animation that I made that sort of zooms up on that landing site. That square in the middle is 10 kilometers on a side, about 6 miles on a side. And that's the area that Viper is going to explore. Something I'm doing more broadly is sort of illumination studies of the surface of the moon near the South Pole, because that's a place that's unlike any place else. Even on the Earth, the sun never gets more than 1.5 degrees above the horizon. And the Earth kind of stays in the same place. It sort of bobs up and down. But if you're standing on the surface at the South Pole, the Earth is upside down. That's South America that you can see in that picture, and rotating backwards. So the environment there is very different. When we send both robots and people there, we're going to have to figure out how to deal with the fact that the sun is never very high. Half the time it's below the horizon. We may be designing EVAs and operations on the surface that rely more on Earthshine, the reflected light from the Earth, because the Earth is 40 to 75 times brighter than the full moon. But you have to take into account what phase the Earth is in, and whether it's a cloudy day, which makes it brighter. And honestly, we're not 100% sure that people in particular are going to be able to operate in the dim light of the reflected Earth. So that's something that we're continuing to look into. And I'm continuing to sort of visualize the lighting conditions to try to speak to that. So I thought I would give everybody a little heads up about how I do this. Chris Meany made that picture of LRO because my modeling skills are not great. If it doesn't involve wrapping something on a sphere, I'm not sure what I'm doing. But this is how I make a moon. I start with this map of the color of the moon. This has every point on the surface illuminated at the same sun angle. And then I add to that a map of elevation. And in this image, the bright areas are very high and the dark areas are very low. You can kind of see it's a funny shape, but you can see how low the entire South Pole Aitken Basin is at the left and right edges at the bottom of that map. It's one of the biggest impact features in the solar system. And the software that I use knows how to wrap these two maps onto a sphere. And then all I have to do is calculate where is the sun, where is the earth, where are the things that I want to show, and it will automatically figure out the shadow, the shading, the lighting conditions, and that's how I make most of the imagery of the moon that I make. The good news is that I've released both of these onto the SVS website. In fact, everything that I've shown you is on the SVS website. I'll tell you about that in just a second, but I wanted to show you too what my software looks like. In the upper right, it's showing me the sphere with the moon maps wrapped onto it, and all the other stuff is telling the software how to paint the surface and how to add that illumination or the elevation map so that it can accurately depict the shadows. This is the homepage of the SVS website. And I encourage everybody to go there and check it out. We have thousands of videos, and it's not just about the moon. I happen to be the moon guy in the studio, but there's a lot of earth science and all kinds of cool NASA stuff there. I feel very fortunate working in the SVS and also working with the LRO team that includes Kayla and Staci. I get to deal with this really excellent data. I get to interact with people who are very good at communication and telling the public about what we do, because that's basically my job, is to take the data and exhibit it in ways that educate people about what NASA is doing. And I also get to interact with scientists who are actually, working with the spacecraft and collecting the data and forming it into things that can be used by other people. So if you'd like to make your own moon, you can go to the SVS website and look for something called the CGI Moon Kit. It's currently one of the most popular stories, which makes it easy to find. You just click on that most popular stories link at the bottom. But this will give you the maps that you would need to use in your own 3D software to make moons at any time in the past and the future. And you can do that with free software too. There's free 3D software out there, so you don't have to make a big investment. And that's my little deal. That's my spiel.
Awesome. Many thanks, Ernie, for that peek into the amazing world of data visualization. I know Dave Prosper, who has been helping us with links and chat all night, has been pushing some links to those visualizations out across our streaming channels. So if you're out there watching and you would like to see more, please do check those out. They're really beautiful and very, very informative. And so glad we got to hear from you about those today, Ernie. Thank you again for coming with us here. And thanks everyone who's still out there hanging out with us. We're so glad to be here with you. We're going to hear now from Marina Gemma, who is a PhD student at the American Museum of Natural History. And you all just heard a little bit from Ernie about data visualization. Marina is going to show you an interactive data visualization software that is available to you, open for your use. And we will transfer over to Marina now. Welcome, Marina. Thanks for being here.
Hi, Kayla. Thanks for having me.
And Scott, would we be able to spotlight both Marina and open space for this segment?
Let's see, let's do Marina first. Okay, and what is the other one?
Open space. It's another video feed in this one.
Ah. Well.
Sorry to make things difficult for you.
No, that's okay.
We will get to the virtual moon with you, Marina. Shall we do a good old-fashioned, everyone turn off their videos and we go to gallery view?
I don't know that I have open space as a video.
Oh, so Marina is logged in twice, and one of our Zoom guests is named Open Space.
Ah, okay, thank you. Thank you. Let me see. I see it now. There we go. This is a first, okay, for me. Here we go.
Fabulous.
Scott.
Thank you, Scott.
Yep.
You can also take me away. I don't need to be on screen necessarily, but okay, thanks for sticking through some technical difficulties. Like Kayla said, my name is Marina and I'm based at the American Museum of Natural History in New York City. And just on the other screen right now, you should be seeing a nighttime view of the New York City area, which is where I'm based. And I'm showing you this view using the OpenSpace software. So kind of similar to what Ernie was talking about, this is a data visualization software, and it's a free open source program that's funded by NASA and developed out of the Natural History Museum where I work. So it originally was developed as a planetarium software, but it's scalable to all different platforms. So from your laptop screen to a classroom projector, all the way up to a planetarium dome. And it takes all different kinds of data sets from NASA and visualizes them so you can interactively explore the universe. So it'll take you from the surface of the Earth all the way out to the cosmic microwave background, which is essentially the edge of the universe. But today, we're going to be exploring the moon, and I'm so excited to be here with you all to do that. So now that we're kind of looking at the nighttime view of Earth, we're going to flip around and start to explore the moon. So I'll take us over to the moon now, and you're seeing a dark moon because you're seeing the moon as it would appear in the night sky tonight. So it's in the waxing crescent phase. And it's cloudy here in New York, so I can't see the moon tonight, unfortunately, but the fun thing about OpenSpace is that you can visualize it as it would appear in your sky. But so we can better explore the surface, I'm going to turn off the shading on the moon. So the entire near side is now illuminated for us. And this is going to make looking at all the features on its surface a little bit easier. So one of the cool things about OpenSpace is that you can look at different kinds of data. And you guys have already seen topographic data sets, but I'm just going to show you one more. So this is a topographic data set of the moon. And so the brighter colors, the greens and yellows, correspond to higher altitude terrain, and the blues and the purples correspond to lower altitude terrain. So you'll see that the bottoms of the craters are always darker in color than the rims. That's because they're lower in altitude. So I can pan around the moon, and now we're approaching the far side of the moon. And you'll see Earth come into view any second now, right there. And I'll just stop here briefly to show that the far side of the moon is much more cratered than the near side of the moon. And so this topographic data set really emphasizes that. So especially in teaching, if you ever need to kind of go over more difficult concepts that are easier to explain with visuals, OpenSpace is a great tool to do that. So I'll swing around to the near side again and take you down to the surface of the moon to explore the Apollo 17 landing site. So I'm going to focus on the Taurus Littrow Valley, which is where the Apollo 17 mission landed. And you'll notice as I'm zooming in, the data initially looks a little pixelated. And this is because OpenSpace is continually pulling these data sets down over the web and rendering them in real time. So depending on how big the data set that you're looking at is, it could take some time to load. But once it does, you'll get the full detail of whatever data set you're hoping to look at. So I'll zoom in here on the landing site of Apollo 17. And actually, before I do that, what I want to point out is that we have multiple different data sets layered on top of each other right here. So we have the initial global data set of the moon that we're looking at. And then we have a smaller scale USGS map, and then an even smaller scale data set here. And so that's another benefit of open space, is that you can look at multiple data sets at the same time and toggle between them as you see fit. So we're zooming down right now to the landing site of Apollo 17. And what you'll notice is the lunar module right there, kind of in the center in the brighter area. And we actually have a 3D model of it coming down and touching the surface. You can change time in open space as well, which is cool because any kind of time dependent phenomena that you wanted to show, such as, you know, phases of the moon or the landing of the Apollo missions, you can move through time and show that as well. But I'm going to zoom down to the surface for now and show you guys right where the lunar module landed here in the center. If you look really closely, you can see the tracks made by the Apollo 17 rovers. So lots of different data that it's integrating here. And I'll show you one more cool thing that we have, and that is photogrammetry of boulders from the Apollo 17 excursions. So I will show you guys Station 6. So this is just the name of this particular area that the astronauts traveled to. And what you'll notice is that they focused on this boulder right here, which actually rolled down the hill above this site. And the Apollo astronauts took a bunch of photos of this boulder and from all different angles. And so through post-processing, we were able to combine all of these photos and create kind of a 3D perspective of the rock, even though we don't necessarily have true 3D data. Whoops, overshot that a bit. And what you'll notice, because we're integrating a lot of different data sets right here, is that the boulders, this 3D structure, is hovering over the actual surface terrain. And that's just because you have different height maps and different color maps. And so the two that I have turned on right now aren't in sync. So that's why you're seeing a little bit of an odd scene right here. These rocks are not floating. That's just an artifact of the software. So you can explore these as much as you want. There's also some other boulders that we have in the software. And you can, zoom right up to the center of these and look at the inclusions in the rocks if you're so inclined. But yeah, this is just, I think, one of the coolest things this software has is incorporating multi-dimensional data. So I'm happy to take any questions if anybody has any, but I really encourage you to explore this software if you're interested. It's at openspaceproject.com and it's free to download and free to use. You do probably have to have a pretty good graphics card to render all this data, but if you have a little patience, you can really, really explore a lot. So hope that was a little bit helpful, and I am excited to be here with you all, and thanks so much for having me.
That is so cool. Thank you, Marina, for showing us around in open space.
Awesome. There's a question in the chat about how big that moon boulder might have been.
Ooh, I would say probably the size of a small car.
Yeah, great.
Yeah,
Thanks.
My guess. We need an astronaut for scale in there, maybe. Can add that in.
Ah, cool. Thank you so much. That was great. So Ernie's creating all this great visualization and Marina is showing us cool ways to use it. And anyone is able to run this with a good system. We could be planetarians ourselves. Is that true?
Absolutely, yes.
That's so cool. Thank you. Really
Thank you
appreciate
guys.
it. Next up, we've got many of you know of Astronomy Picture of the Day, or APOD for short. We've got Robert Nemerhoff, who's joining us from Michigan Tech University. He's the principal investigator for APOD, along with Jerry Bonnell. And he's going to show us some amazing views of the moon from people who have taken images all over the world, and NASA as well, of course. Take it away, Robert. Thanks for joining us.
Okay, thank you, Vivian. Thanks for having me. This is great. So observe the moon. These are some best APOD images. So APOD stands for Astronomy Picture of the Day, which you can find at apod.nasa.gov. So we've been around for quite a while, since '95. Every day we feature another image at this website address, and we have a lot of good images, and we're currently one of NASA's most popular sites. So let's get to the moon images. And what's this? Is this the moon? It looks like the moon. It's got lots of craters. It seems to be moon covered, but kind of looks like my background, but it's not the moon. It is Mercury. So there's lots of cratered things in our solar system, moons and planets, and so Mercury is one of them. It's a lot hotter than our moon. It's a little bit bigger than our moon, but not much bigger. And so NASA's MESSENGER satellite took this 10, 15 years ago. But exciting news, just this month, Bepi-Colombo collaboration between Japan and Europe just zoomed by Mercury again, and it will eventually return and orbit the first planet out from the sun. Okay, so if that's not the moon, is this the moon? This is not the moon we know. How can the moon look like this? That's because this isn't our moon, no. So which planet does this moon orbit? You can just shout that out, it's good. People around you will want to know. Make sure your neighbors can hear you. What's what? A little bit louder. Okay, yeah, that's right. It's Saturn's moon, Iapetus. And it's sometimes called a painted moon. What we're seeing is the trailing hemisphere as it goes around Saturn, and the leading hemisphere is a little bit unusual, more than a little bit unusual. It's dark as coal. It's dark brown, and there's some kind of carbonaceous material there. And this is the more lighter material, much different in brightness, that trails it. So this is mostly the trailing hemisphere. And here you see down here a big crater. So let's keep looking for the moon. Oh, there's our moon. Do you see the moon? Find the moon. So this was an APOD on. You can find all these images on the Astronomy Picture of the Day. The day you find them, we have an archive of all of our images. You just go to the July 11, 2021, although it appeared previously. So this was taken from, this picture of the moon is taken from Colorado. So if you think the moon is on the left, raise your left hand. If you think the moon is on the right, raise your right hand. If you think the moon is in the center, raise your center hand. I don't know how that works, but so raise both hands. There you go. And so the answer is, drum roll please, it's right here. Now, how come the moon we see is brighter than this moon? Because this moon was taken during a total lunar eclipse, for one thing. And another thing, it was taken just as the sun was rising. So it's a full moon. The sun is just rising and illuminating the air. So there's a lot of air glow here. Also, there's a lot of attenuation due to the Earth's atmosphere. So even the full moon isn't as bright as we remember it. And sometimes you have to look at it. The photographer who took this, Jimmy Westlake, said that he knew where it was when he took the picture. And then when he looked at it, he couldn't find it. He knew, even knowing where it was, he couldn't find it. But if you put your eye right up against your monitor or your phone, you can see it. Put it right up there. It's okay. People aren't watching. Okay, good. Okay, is this our moon? And left hand is, your left hand is yes, your right hand is no. And the answer is yes, it is our moon. But it is not what you usually see. It is the moon from Zond 8. This picture was taken in 1970 by the Soviet Union spacecraft, which Zond 8, which went around the moon and took film pictures, came back to Earth, and this is one of those film pictures that was developed. So this is Mare Orientale here, and there's some Maria, which means Latin for ocean, but it's not seas. They're not seas, they're dry. And but you can see the highlands that we just saw last lecture. The far side of the moon are much higher and lighter than the Maria. And so we had seen the far side of the moon before, but this really brings it into focus, how cool it is. Okay, so here's another moon. This is the standard moon that you might see. So here you can try to find not the moon itself, but the man in the moon. As we heard last hour, there's more than the man in the moon. There's a fox in the moon, which I had never heard before. I heard of the woman in the moon, and there's actually a couple rabbits in the moon. And many cultures have a lot of moon myths, which is beautiful. In the US, one of the favorite moon myths is the man in the moon, which could just be a person in the moon. But it's known as the man in the moon. That's the search topic you would use if you went on Google. So can you find the man in the moon? Everyone's seen it, but do you know where it is? And so here's one, there's many ways of doing it, but here's one way of doing it. You take these Mara, and they're the eyes, and then you put the nose, and this is the mouth. So if the moon is at the right orientation, which depends on your hemisphere and latitude and actually time of night. But if so, then you can find the man in the moon. But there's actually two people in the moon here. The other one is this guy right here, who's looking at an image of through his telescope at the moon behind it. So when you observe the moon, you can see the man in the moon, and you can look through a telescope and see fine details on the moon. Okay, so this is the moon, not a moon you might be familiar with. So this person who took this moon, Brent McKeon in Manitoba, he was gone to work one morning, and he went outside and he looked up where the moon would be, and this is what he saw. Wow. And so he was late to work because he just couldn't believe it. Fortunately, in our era of smartphones, he was able to take a picture of it. So what we see is the lunar halo in the center, and we see moon dogs on either side, and we see tangent arcs on top and bottom, and circles caused by floating ice crystals that flitter down most of this. And so when you look through ice crystals, these ice crystals can reflect certain things, and you can see really cool stuff. And so this is a really great image, a colorful image of moon too. So when he then drove to work, almost all of this disappeared within a few minutes, and you could see only one of the moon dogs. But if you see this, take out your camera and take a picture. And if you want, send it to us. We'd be happy to see it. Okay, this is a really close-up of the moon. It's hard to get this from your backyard. In fact, the best way to get this is to go to the moon. So that's what humanity did. And this was taken in 1969. And this is a picture of the first person on the moon from the second person on the moon. This is a picture of Neil Armstrong. And he's standing on the moon. And this is a pod of the lunar lander. And the moon is described, and we heard it just this hour and even last hour, a magnificent desolation. It's kind of empty back there. I mean, there's some craters you could look at and there's hills, you can look at my background, but it's kind of empty. It's kind of desolate, but it's really cool at the same time. So Buzz Aldrin, the person that we're looking at, is the person who coined the magnificent desolation phrase. So even this one, though, was taken in 1969, just this past year, someone took a look at Buzz Aldrin's visor, which is like a spherical reflecting surface. And that's here. And with the miracle of modern software, inverted it to create an image of what Buzz Aldrin would have seen looking out of his visor. And so this is Neil Armstrong on the moon, as reflected from the visor, which is included here. And this is, there's certain space, there's measurements, there's Buzz Aldrin's shadow here, and there's Neil, and you can see here. And if we go back to the last one, let's see if I can do this without crashing everything. So you can see all of this here. There we go, and then we go to the next one, and here you see it again. But this is the reflection. Cool. So you see it over here, and there's Neil Armstrong. So a miracle. So he was able to find really high resolution images of the moon. So the film images of the moon are really incredibly high resolution. So this has been inverted. So we just did that this year. So it's done by Michael Ranger, who did this. So a lot of the cool images of science are now done by citizen scientists who take data, including NASA data, and reprocess it in some way that's scientifically interesting and visually interesting. And that's what this person did. And there's lots of data online that you can too. You can do it with Hubble data. People are doing it with Juno data around Jupiter. And I think future missions will have the ability to do that too. This is one of our most favorite images, or one of the most popular images from 2020. So this is the moon, showing mostly by Earth glow. But this moon, taken in Guatemala over a Guatemalan volcano, it looks a little bit like Saturn because of what seem to be rings, but those are just clouds. So it's actually a crescent moon, and you can see some background stars too. But the juxtaposition, the one thing looking like another, is just really a powerful icon. It's a combination of two icons. When you look at it, you can see the features of the moon. But when you look at this, it kind of looks like Saturn, and it's all in one shot. It was one shot. Okay, so the last one I have, it's called Eye of Moon. This was taken in Utah. It was taken by a citizen scientist again, and you can see a gibbous moon here. And so what this person did is they used several apps. So you'd think, oh, just take a picture of the moon through the arches, national monuments, one of the arches in Utah, just go do that. But you have to time it right, and you have to know where the moon's going to be at a certain time. So Zachary Cooley did this, and he computed things again and again and again. And he went up there, and he had people looking through the arch too, and he found the moon in the arch and got a picture of it and sent it in. And so this is called Eye of Moon. And this is some of the cool images that we feature. So let me plug the Night Sky Network again. If you're out there and you're not a member of the local astronomy club, maybe you should check it out. And one way to do that is on nightsky.jpl.nasa.gov. And if you want, you can come back and see our site anytime at apod.nasa.gov. And that's what I have for you. So,
oh, Robert, I love this. Thank you so much. APOD is just one of the most magical websites around. You can make it your screensaver. You can do so many things with it, and people have taken it in all sorts of directions. So thank you so much for joining us. Those were great moon images. Really appreciate it. Oh, and last but certainly not least, we have Dr. Brian Day joining us. He is coming from the Survey Institute, and he has one of the coolest systems around. He's the Survey stands for Solar System Exploration Research Virtual Institute, which is a mouthful, which is why we call it Survey. He's a deputy staff scientist there, and he's going to be telling us about moon trek. That will be one more way that we can almost feel like we're on the moon, and you can do this from your home computer. So check it out. Thanks, Brian.
Thank you very much, Vivian. So let's see, I think if you could bring up my video feed here and get it going. So today I'd like to provide you with an overview of NASA's Moon Trek online portal. This site allows you to explore the surface of the moon as seen through the eyes of many different instruments aboard many different spacecraft. Designed for lunar mission planning and science, MoonTrek is also a great resource for the public and students from K-12 through graduate school to explore the moon. MoonTrek is free for you to use. You don't buy anything or install anything. Just point your computer's browser to trek.nasa.gov. And when you do, you'll see a number of worlds you can select from. Today, we're going to select the moon because, well, that's what we're doing today. And we'll zoom into the moon here, click Explore to bring up the portal for the moon. And you'll be offered a chance to take a tutorial of how to use the controls. Right now, I'll be your tutorial. And like any good GIS system, you can zoom, you can pan. And what we'll do is we'll zoom and pan here to the crater Tycho. And one of the first things you might want to know about Tycho is, well, how big is it? Well, using our distance calculating tool, that's as simple as drawing a line. We'll just draw a line across Tycho here. We'll see that it's about 85 kilometers across. It's a big hole in the ground. You might also want to know how deep it is. And again, that's as simple as drawing a line. We'll extend the line on either side now so we catch the rim. And let's move Tycho a little bit off to the side here. You'll see we can very easily get a nice elevation profile. You can measure the heights of mountains, the depths of valleys and craters very easily with the MoonTrek portal. You can also draw a bounding box around any landform you want. So we'll draw a rectangle around Tycho here, and it's going to come back. It's going to ask us if we want either an STL or OBJ file that you can send to your 3D printer. You can make 3D prints of any area you want. We also have the Experience Trek VR tool. Draw a path you want anywhere across the surface of the moon, and it'll come back to you with a QR code. Scan this QR code into your smartphone, and whatever path you drew, you will now fly in virtual reality. Just put it in a pair of Google Cardboard goggles. You can switch a number of projections. We're going to jump here from a flat equirectangular projection to now a 3D globe projection. And interactively, we will go flying just using the keyboard game control keys and our mouse. We can fly down into Tycho crater. It's actually a lot smoother when you're not piping it through Zoom here, but we can fly down into the crater. You can fly all across the surface of the moon. It's a great way to go exploring. It's a lot of fun. And you can see all kinds of features coming into view. So now, while we're in the 3D mode, we'll bring up another tool. This is our country mover tool. You can select any US state or any country around the world, and you can overlay it on top of the moon, drag it, and so you can compare landforms on the moon to landforms that you might be more familiar with here on Earth. Get a real good appreciation of the size of features. Now, you can navigate very easily with our Fly To feature. You can either enter a specific latitude or longitude, or you can enter any place name you want. We'll type in Marius Hill here, and we'll fly to the crater Marius. And the reason we're going to Marius is because Marius is surrounded by the Marius Hills, some of the most spectacular volcanoes on the moon. It doesn't look too spectacular here, but we have over 10,000 different data layers here. Many thousands of data layers, and we can view the moon in many different ways. And so what we'll do is we'll pull up a laser altimetry view here, and we can get a detailed view of all the ups and downs. And now we can see hundreds of cones and domes popping into view. Again, there are many different data layers we can work with. So now we'll go ahead and bring up a different view of this same area. Now we'll pull up a gravity map from the Kaguya probe. And this is going to show us the same area very differently. We'll see a gravity map with red areas being high gravity, blue being low. And you can just add different data layers into a stack, and you can rearrange items in your stack. For each item, you can toggle it on and off. You can see an abstract about that data product. You can view here, for instance, what does the color coding mean here? You can see the metadata, the actual provenance of this data, how it is appropriately used, so you can get into the real nitty-gritty. You can download the data. So if you have some other software that you want to use this data in, we provide you with the means of downloading that. But really cool is you can then adjust the transparency, so you can blend different data layers together. And in doing so, here now we see the surface topography of the volcanic field, as well as now the unerupted plug of magma beneath it. When you do a visualization like this, you might want to save it or share it. And since it's all browser-based, we generate a URL for you that you can copy, paste into an email, send it to your friends. They load it into their browser, and it'll bring up your visualization. The South Pole is of great interest right now. We're about to send a lot of robotic missions and some human missions to the South Pole. So let's take a closer look. We can see that this is an area of intense shadowing. The sunlight is coming in essentially horizontally, and a lot of the terrain is really obscured from view. But if we switch to a laser altimetry view, we pierce those shadows. This can be very helpful in planning traverses. We can really see the details of where we might want to go. We can also generate a slope map. Red is slopes you might want to avoid. Blue is fairly nice and level. We can overlay areas of permanent shadow where the sun hasn't shone in over 1 billion years. And this is areas where volatiles like water ice can be accumulating. That's a key resource. Another thing we might want to do is look at thermal data. So here we have average temperature from the Diviner instrument. Maximum temperature, again, really good for isolating where water ice might be located. Let's take another view here. We'll look at hydrogen abundance, again, as a marker for where we might find water. And we can also do a map of ice stability at depth, thermal modeling. How far would you have to dig down for ice to be stable? And in those permanently shadowed areas, it's stable right at the surface. Let's do a wrap up with a tour of some sites. This is the Apollo 11 site visualized with Moontrack. You can see the descent stage, you can see some of the instruments and the footprints of the astronauts. Here is the Apennine Mountain front with Hadley Rill, visited by Apollo 15. And we can zoom down a little closer to Hadley Rill, looking across it and looking up at the slopes of Mount Hadley Delta. We can take a look at the Apollo 17 landing site. We saw that a little bit earlier. And you see this valley, the Taurus Littrow Valley, deeper than the Grand Canyon here on Earth. This wonderful landslide coming off of South Massif that was apparently triggered by an active fault there, the Lee-Lincoln Fault. Going to Lacus Mortis is a place we're going to go next year with a robotic mission, and within Lacus Mortis is the crater Berg with this great landslide on its western rim. The Aristarchus Plateau, fantastic area, lots of volcanic activity as exhibited by Schroeder's Valley, among many other volcanic features. And speaking of volcanoes, the Gruithuisen Domes have recently been named as a destination, tall, steep volcanoes with thick, viscous magma. And this is the mountain Leibniz Beta. Its flat top is going to be the exploration zone for the Viper rover as it prospects for water. We have 3 craters that have just received names in the last few days. Matthew Henson, Ursula Marvin, and Paul Sputus were honored with craters near the south pole of the moon. So these are just the types of views you can do sightseeing across the surface of the moon with the Moontrek series of portals. There are portals for a variety of worlds. I encourage you to visit trek.nasa.gov, and I tip my hat to the brilliant team at JPL that I get to work with. Thank you all very much.
Well, that was really awesome.
Yeah.
And I think that our audience has learned so much about the moon, probably more, with all the presentations and stuff, especially this last one, more than our audience ever knew about the moon in their entire lifetime. So really fantastic. Really fantastic. Thank you.
Well, thanks to all of you. This has been, what an incredible day. Just
And
amazing.
I want to point out to everyone that Brian is also one of the founders of International Observe the Moon Night. He was there when the idea for this program was conceived, and he makes our beautiful moon maps every year. So this is his work that you all get to enjoy year after year after year with all of the different features described. So this has been amazing. I always love hearing from Brian, and I get to work closely with Ernie, and everyone on here tonight has just taught me so much. So thank you all so much, and thank you all for being here. This has been just a fantastic evening.
Awesome.
Andrea, real quick, I need to give a hat tip to Ernie Wright too on those moon maps that we use every year. So amazing work. All of these people are doing such incredible work.
And you and Ernie are combining for a moon viewing tool every single day of the year. So look for that in the next few months. We're going to have any day of the year. You can pick out a day and decide, or if you're going to be in a place with a good viewing location or just from your back porch or anywhere, you can see what is a really cool feature to look at today. And Ernie and Brian and Staci and others, and Kayla and several others are working on that one as well. And Vivian's helping us improve that too. So lots of minds combining to bring you more great moon things throughout the entire year. So thank you all so much.
Lots of minds, theme of the night. I love it. Yes. Thanks so much to all of our Hour 3 folks. And stay tuned, everybody. We are going to finish strong for you tonight with a little bit more moon feed from Slooh. We are going to end with some music. We've got some wrap-up information for you. But first, Vivian has got a little change of pace for us.
All right, so check this out. I want to give a big shout out to John Goss, who was here earlier. Let's see. We have a little moon trivia for you. I hope you can see that. All right, so imagine you had a car that could drive through space. If you're going 60, 70 miles an hour, we're calling it normal freeway speeds. How long would it take you to reach the moon? You can add that in the chat. You can add it. You can just turn to the person next to you and guess. And I'll just give you a minute. This is from the Astronomical League's 75th anniversary. And John created quite a few of these that we'll be sharing soon. So, all right, I hope you've had time to guess. Anybody here want to guess?
And I would guess 143 days.
Yeah, right. It's specific.
It's pretty far.
Right. It is far to the moon. You could fit 30 Earths in between the Earth and moon. So although it took the Apollo astronauts just 3 days, a little less, they were going a lot faster than my car does. So there you go. We've got a lot of fun factoids to share. And I hope you can use some of them for observing the moon night. I'm going to stop share. All right, we've got everybody, and let's.
Okay, so what we have left is we do have more of the video feed from Slooh. We have One Small Step from WinSync. And then
before we go there, sorry, go ahead, Scott.
Go ahead.
I want to make sure that some of those links that we shared way back at the very beginning and a couple of others make their way to all the folks who are out there with us tonight. Hopefully.
If I can why don't you put those links in the chat, and I'll paste them in here so people can directly link on them. And I will also put them up as far as something that can be used as they watch us in the future.
Awesome. And thank you, Scott. And thank you, Dave, for keeping the chat running as we have been going tonight and getting all those links out there. These are the people who are making this night happen. Much appreciation to you. I think Dave's got some of those links coming to you across those channels as well. Ways you can get involved and stay involved in International Observe the Moon Night include you can add yourself to the global map of lunar observers on moon.nasa.gov/observe. By registering your participation, you'll actually see yourself show up with observers all over the world, which is really fun. There are all kinds of ways you can participate in International Observe the Moon Night. As you have probably gathered, if you didn't already know, we interpret observe broadly, and we look forward to seeing how everyone chooses to observe the moon over the next couple of weeks and beyond. If you would like to share your experience and see how other people observe the moon all over the world, we invite you to browse our collaborative Flickr gallery for 2021 and to contribute your own images. And these can be photographs from events, these can be lunar themed art, whatever you are doing to mark International Observe the Moon Night. We would love to learn about it. Finally, for me, I just want to make sure everybody is aware that if you want to stay tuned in on social media, #ObserveTheMoon is the way to go. There'll be lots going on, and we hope you'll join the conversation. And I know Vivian has a couple of additional links to share with you all before we move on.
Thanks.
Sorry.
I was just going to say, I want to let everybody know that we want to hear all about how it went and what you did, because that's really exciting for us and helps us plan future years. So we've dropped a couple of the observer surveys in the chat. There's one for if you are an observer having your own observations of the moon part of the moon during this week or so. And then there's another one for event hosts who are hosting events that involve more people. And if you could just they're very, very short, take a couple of minutes to let us know what you're up to. That'll help us keep the moon party rolling. So I want to thank everyone so much for joining tonight. This has been one of my favorite events we've ever held. Thank you.
Thank you very much. Thank you. So we'll just run past those links. Anything else anybody would like to add before we roll the end credits here?
Let's see some moon feed from Slooh. Thank you,
Okay. All right.
Slooh.
Well, let's show this
Thank
first.
you, John,
Okay.
for providing.
Here we go.
Sure.
And I also, for people watching that are on the live chat, you can click through those links. For sure, you're going to want to respond back to Vivian and the Night Sky Network people on what you'd like to see for a future event. So hope to do this one again. It was just such a blast. And we'll switch over to that feed from Slooh. Here we go.
Thank you, Scott. I know we had some folks asking about telescope live feeds in the chat at the beginning of this event, and we will have more than one telescope live feed going on next week, 1 week from today, on International Observe the Moon Night. So if you join the NASA TV broadcast, that'll take place at 10:30 Pacific, 1:30 Eastern, 5:30 p.m. UTC. You'll catch more from Slooh. We'll also have a telescope live feed from Gianluca Masi at the Virtual Telescope Institute in Italy, who we heard from earlier this evening. And of course, lots more on the live broadcast next week. So we'll hope to see you there. And Viv, Scott, Andrea, is there anything else that you'd like to add before we play ourselves out with a final installment from WindSync?
Thank you. We hope you have a great time observing the moon.
That's right.
And share it with us. We can't wait to see how you're doing it. Thank you.
Thank you. Thank you. And to everybody that appeared on the program, my gosh, it's just it was like an all-star, lineup here. So I can't imagine having a better group of people to help interpret what the moon is all about. So, okay. Thanks again, and make sure that you celebrate the International Observe the Moon Night, and consider joining a Night Sky Network astronomy club if you don't belong to one already. Good night.